Kumar, who is working now in Green Co and AM Greens and Green. He talked about the prices of green hydrogen, which has come down to about 335. But the point for mobility is that you have to, that's 335 is without GST, and if you add GST, it comes to nearly 400, which is around $500. And then if you add the cost of transportation and delivery, it will not be less than 550 or 600 rupees at this point of time. Having made that point, these colors, if you produce it from coal or natural gas, then brown, gray, blue. Blue is if you can capture carbon and utilize it or sequester it is underground, then it is called blue hydrogen. Green, of course, you get it from renewables. Biomass, turquoise, and then there is a color given for nuclear, and there is people talking about white hydrogen also. I don't want to get into. This is the mission which Dr. Ramkumar also mentioned about National Green Hydrogen Mission. It talks about 5 million tons of green hydrogen to be produced by 2030 primarily from renewable sources like solar and wind power based. It is also supporting the manufacturing of domestic analyzers, electrolyzers, green ammonia, and also some of the projects for ecosystem development. They are supporting the pilot projects in steel, shipping, transport, R&D, testing facilities. Dr. Sujit Pillai, who is spearheading the R&D project, is here. You will be listening to him in due course of time. This mission is primarily for pushing green hydrogen, which is the right way, perhaps, for a country which is the net importer of oil and natural gas. Now, you look at this particular slide. The current hydrogen demand in India is about 7 million tons. Sorry, it has not changed over there. Sorry. Oh my God, I didn't change over there. I was changing here. There is no synchronization. So I will go back to this colors if somebody was just want to see that. Okay. Sorry about it. So then we go to the next slide. This is about the National Green Hydrogen Mission. I was changing here. I thought it was changing over there also. So this is, if you can want to have a look at that. Change over there. So this particular is about the mission activities which I described. Then this is on, you can change the next. Yeah, I will do it now. Change. Okay. So this is the hydrogen current demand is about 7 million tons in India, which is primarily going for refineries and fertilizer units. It is likely to grow up to 13 million tons by 2030, the total hydrogen demand. And by 2050, with a lot of hydrogen economy getting developed, it is likely to go to 30 million tons. So the demand scenario, if you look at, the global hydrogen demand, 90 million tons, which will grow to 200 million tons. That's the kind of growth which is going to happen in the next 5 years. And over 500 million tons by 2050. And over 6 million tons is required if you have to have that 1.5 degree scenario for global warming protection. Majority of this hydrogen, as I mentioned earlier, is being produced from natural gas reforming. China does a lot of coal gasification to produce hydrogen. I've also been wondering sometimes that we also have large reserves of coal. Can we have clean coal technologies for producing blue hydrogen in the country, where you can capture CO2 and convert it or sequester it or convert it to some useful chemicals? That's the way we can debate. Hydrogen demand, as I mentioned, 6.7 million tons to be 13 million tons by 2030. And if you look at the National Green Hydrogen Mission target of 5 million tons, there is a gap of 8 million tons. So by 2030, I presume that if we have to meet the hydrogen demand, we will be producing more of gray hydrogen than what we are producing today. So we need to focus upon more on the CCUS kind of technologies, producing blue hydrogen. Now, if you look at the cost of hydrogen, the next slide. The cost of hydrogen, this is a particular slide which I just took it from IEA, where they had compared the cost of hydrogen production in China. You can see if you use grid electricity, the cost is quite high. Renewable electricity also, they thought that this is even lower because grid electricity possibly is the fuel costs are much higher in China. But I leave aside the grid electricity. But if you look at renewable and natural gas is lower. CO2 is shown in that circle, small circles. That's the carbon dioxide emissions. Look at coal. If you have this, cost is the lowest in case of coal, but the circle is high, the CO2 is more. But if you can do with CCUS, the carbon capture and utilization, which converts it into gray or brown hydrogen into blue hydrogen, then the circle is quite low. It is not much ahead of, slightly up than the renewable electricity based, and slightly more than natural gas based CCUS, but still much is not much. And if you look at the standard of 2 kg per CO2, which has been developed for Indian green hydrogen, if we can have efficient CCUS technologies developed through the research and development, I think that is also opens up opportunities even for utilizing the coal as China has been doing. Because ultimately, if you go to more of renewable electricity and shift from coal-based power, what to do about that? So to cover that gap of hydrogen in the production side, you can look at other options also. So natural gas also is an option which reduce lower cost is there. If you look at these costs, these are much lower than the figure which we are talking about green hydrogen. I'm not saying that we should not go to green, we should go to green. But you have to see the affordability, the cost, etc. also. Look at the coal and natural gas based plants, and these are the costs developed by Engineers India Limited and also published from some other sources. The type of comparison is shown here. Now look at the cost of green hydrogen. 1 kg requires 9 liters of water, 45 to 55 kilowatt of electricity at present. Electricity alone costs you minimum 250 rupees. Cost of electrolyzer, depending on what add another, is about 150 to 250 rupees. The green hydrogen, as was mentioned, will be around at least 400 rupees kg with GST, mentioned about the price which has been discovered. And if you have to deliver cost, it will not be less than 500 rupees. The cost of electrolyzers have fallen by 40% in last, need to fall further in order to make green hydrogen affordable. Another issue is the availability, how much green hydrogen you can allocate. For 5 million tons also you need 125 gigawatt of electricity. So how much you need to do that? These are some of the issues which should be also deliberated. We need to reduce the cost of electrolyzers. We need to produce more of renewable energy. That's how we can do. Another issue is the biomass hydrogen. This has a large potential in a country like India, where you can use surplus biomass from agro residues and forests and wasteland and then produce hydrogen. You can do biomass gasification, well-known technology of syngas and then water gas shift reaction. And then if you can capture CO2, it will be negative CO2 kind of hydrogen production. So this is, several companies are setting up the CBG plants, compressed biogas plants based on biomass agriculture. Government is guaranteeing price of CBG. You can convert that CBG, reform that, and also produce hydrogen. That will be negative CO2 and also low cost hydrogen. It is estimated, many companies have been trying to work on this, and this can be produced at 150 to 220 rupees a kg, which is lower than the renewable electricity based green hydrogen. So this rural jobs can also be created through this route. Now, this is one slide which is from McKinsey's report, where they say that the green hydrogen costs are likely to come down by 2040, 50, and they need to come down. Unless they come down, you will not be able to utilize green hydrogen for various applications, particularly for mobility, where I'm talking. You may still use it for compliance type of issues where the compliance markets have to necessarily. I was mentioning about the cost involved in transportation delivery. So it's not only the hydrogen production cost, which we often talk. You have to purify it, you have to compress it, you have to bottle it, you have to deliver it at site. So many times, if the place of production and the place of delivery of hydrogen are far off, the cost of delivery could be almost equal to the cost of production. So it has to be thought in totality if you have to use hydrogen for various applications. Now the question is, which I've been always talking, is about when to build infrastructure. Hydrogen can be economically produced today, as I showed you, from coal, petcoke, natural gas, brown, gray. You can develop CCUS technology. Some of them have been developed, some of them are getting matured. Niti Aayog, under leadership of Dr. Saraswat, has made quite a lot of effort on developing that CCUS technology in India. More R&D efforts can perhaps bring down the cost of CCUS, can make it more efficient, and that will be opening doors for blue hydrogen in a bigger way. The question is when to build this infrastructure for the entire hydrogen value chain, for production, storage, transportation, supply, and should we wait for green hydrogen costs to come down to affordable level and then start thinking of creating infrastructure? I hope it will come down, green hydrogen costs. But if it comes down suddenly through some more innovative developments, then you're not having infrastructure. So why not start thinking in terms of building the infrastructure for hydrogen usage? Hydrogen can be used as a feedstock. We are using it in refineries, fertilizers. Steel industry is one of the biggest probable customers of hydrogen. Chemicals, you can use it for transportation, which I'm going to talk, power, city gas distribution, ethanol. There are several sectors which will use hydrogen. Hydrogen for mobility can be used in various types, various applications are there. You can blend it in CNG. When I used to be at Indian Oil R&D about 15 years back, we had, more than 15 years back, we had done some extensive trials on hydrogen, which have further been done. Then hydrogen in IC engines. Tata, Ashok Leyland, so many people have been working on this, and then hydrogen in IC engines have been, and it can replace CNG. There are people, some of the projects which MNRE has recently awarded for converting CNG vehicles into hydrogen. The fuel cells, where Dr. Ashish Lele after me is going to talk about this, an expert on development. Fuel cells are more efficient as compared to the internal combustion. So there is a great opportunity waiting, because if you use fuel cells, you use energy in an efficient way. We are net importers of energy, so we save energy. Now looking at the hydrogen as a fuel, it has 3 times more energy on weight basis as compared to natural gas, but on volume basis it is low. So you have to store it and compress it at a much higher pressure. Now look at this next slide, which is from next. This is a quote which I took from Chief Technology Officer of Tata Motors, Mr. Rajendra Petkar, who's a good friend of mine. He mentioned in one of his talks that as it stands, the battery vehicles are not suitable for heavy-duty long-haul commercial applications. Fuel cells require hydrogen with very high level of refinement, while hydrogen IC engines can operate with lower grade hydrogen and allows the use of existing infrastructure. So based on this, the hydrogen has several properties and challenges also. Hydrogen, wide range of flammability and ignition energy, allows lean mixtures. I don't want to get into these technologies, but it allows higher compression ratio. Look at the third bullet. It's high efficiency. So hydrogen IC engines can be more efficient than the CNG engines. And weight basis, hydrogen has 3 times more energy as compared to CNG. Fuel injection system design, etc. need to be done, but lower energy density requires high pressure storage tanks like Type 4 cylinder for storing. So these are some of the challenges which have already been overcome by the leading producers. And this is an opportunity. I look at this as an opportunity that you can use CNG mixtures also. You can, the high diffusivity property of hydrogen facilitate uniform air fuel mixtures. And in case of leaks, hydrogen is very light, very, and it simply goes up. It is quite safe. People need not be afraid of hydrogen. Hydrogen IC engines are more suited, as even Dr. Rajendra Petkar, he has said it, and more, because trucks are not supposed, it cannot be, we have been talking about battery electric vehicles, cannot run on batteries. They are supposed to carry the cargo load, not the battery load. So for trucks, the hydrogen application is quite good. There are no particulate or carbon dioxide. There are some IC engines of hydrogen. There are some NOx emissions which can be controlled with advanced after treatment, which are possible. And the lower total cost of ownership and lower life cycle carbon emissions compared to battery electric vehicles, etc., is an opportunity. So now look at the hydrogen in fuel cell. There are challenges. Precious metals are required, such as platinum and iridium as catalysts, which makes the fuel cells more costly. Fuel cells durability in extreme conditions and especially under heavy load conditions is another challenge. Competition from battery electric vehicles is there for fuel cells which are rapidly advancing. So hydrogen as fuel cells is an alternative, certainly, because it is 1.5 to 2 times more efficient as compared to internal combustion engine powered vehicles. Thus, a potential for energy savings and reduced carbon emissions in mobility. Vehicle range of hydrogen fuel cell vehicles is also much higher as compared to battery electric vehicles because they are more efficient. Even with hydrogen, they can provide you longer range as compared to IC engines of hydrogen. Fuel cell applications for trains, drones, and auxiliary systems in aircrafts are being explored. So this is a good opportunity for using hydrogen fuel cells for mobility. The only issue is that the cost has to come down. India already sees, the fuel cell bus, NTPC, IUC, they have all developed trucks by Tata Motors, Ashok Leyland. A lot of trucks have already been developed. There is another application for hydrogen in off-road equipment. Most of the off-road construction equipment use heavy-duty applications. Hence, hydrogen IC engine is more suited for technology for this IC engine. Such equipment is used in harsh conditions, high dust, temperature changes, vibrations. So these kind of equipment will not only require high pressure onboard storage tanks, but hydrogen need to be transported to sites. That's another issue that you need to the machines of JCB type cannot come to the fueling station. So you need mobile refuelers for delivery of hydrogen to those kind of vehicles. The PASO approvals is a challenge. JCB, incidentally, they already have a prototype in Ballabgarh, which is with hydrogen IC engine. And I had I was fortunate to have a meeting with Mr. Bramford, the owner of JCB, and he mentioned that he wants to, for world, he wants to produce, JCB wants to produce hydrogen IC engines in their Ballabgarh, Haryana plant for the world market of JCB on hydrogen applications. Hydrogen and its derivatives for mobility. CNG mixtures, I did talk, bio-CNG, etc. can also be blended. Neat hydrogen, internal combustion gensets, off-road equipment, fuel cell, trains, drones. Methanol is for ships, old engines is being thought. You can produce methanol, methanol, hydrogen plus CO2. You can reduce carbon dioxide emissions also. Wherever you capture, you combine with hydrogen and you can produce methanol, hydrogen with CO2, e-diesel, e-kerosene. They can decarbonize aviation, gensets. There are ample opportunities. So India's first hydrogen powered train is likely to be running in Haryana. Indian Railways is almost ready, and this will be running soon. Then the hydrogen for shipping also, the Minister of MNRE, Mr. Joshi, also mentioned that India will become a key port as a hydrogen hub at key ports as part of its green shipping initiative. So that's also underway. So that is the hydrogen use in mobility is going to take off in a much bigger way. Hydrogen powered drones is an emerging area where we have been talking with warfare requires. As drones continue to reshape the nature of warfare, the limitations on range and power are becoming the difference between success and defeat. So fuel cells, which I mentioned, are more efficient. People are trying to use fuel cells for drones. There is a company which I heard that the Paras Defense and Space Technologies has taken a significant leap in India's defense and security landscape by announcing country's first locally made hydrogen-powered drone for defense purposes. There are many companies, many startups also who are working on this development. Advantages of hydrogen over electric vehicles. I just want to mention that we have been talking about electric mobility quite a lot in this country. But let us look at, we always think that they are very clean. Yes, of course, they are cleaning up the city, no pollution. But refueling time of hydrogen vehicles is significantly lower as compared to battery electric charging time of electric. Vehicle range of hydrogen fuel cell vehicles is also much higher as compared to battery electric. Even IC engines have higher range than batteries. The fuel cells they've used will be even more longer. Hydrogen vehicles, the weight of high pressure type 4 cylinders are much lower than batteries load. Hence, hydrogen more suited for heavy duty applications. I mentioned that. Battery vehicles have high dependence on critical materials. That is one of the big issues which the EV manufacturers are already facing about the availability of critical materials like lithium, cobalt, etc. Unless we have innovative battery developments, I think pushing battery vehicles in a big way is a big issue. They are mostly controlled by China. I keep on saying in various forums that India is more convenient and more safe by importing oil from Saudi Arabia as importing critical materials from China, because they are controlling the world market for that. So I don't know. These are some of the issues which need to be. So hydrogen scores better than battery electric vehicles. Hydrogen for mobility. If you look at what I showed you earlier, what Tata Motors said, Mr. Bhargava. He said the electric cars will not be clean until India gets at least 50%. He mentioned 50% from renewables, but I believe that even if it is 70 to 80%, unless you go to 70, 80% of renewable power, uh, maybe India should move, he mentioned, to ethanol, hydrogen, or fuel cell options instead of going for electric vehicles. Now, this particular slide is interesting, which I have taken from a study which has been done by the Fraunhofer University in Germany. Look at this slide, the battery electric vehicles, the middle one with a big red bar. The electricity for battery electric vehicles, if it is coming from grid, which is the current kind of grid mix, you are contributing to greenhouse gas emissions much more than even diesel. Almost, you can see on the extreme this side the diesel bar, and the red, more of red, the third bar from this side is even more. What are we doing? The battery manufacturing also has a lot of CO2 emissions. So fuel cell electric vehicles, even if they use 100% of natural gas-based hydrogen and you have fuel cells, they are lower than the battery electric. They are lower than diesel. If you have 50%, which is now, I believe, the current mix is reaching almost 50% of renewables and 50% coming from natural gas, the fuel cell electric vehicles are much lower. If you have 100% dependence on wind or solar power and then produce renewables, then your emissions are going to be low. But then the cost is an issue, economics. So what is that we have to do? We have to think and deliberate that what kind of policies we should be having. So hydrogen vehicles, in my view, score much higher in terms of even greenhouse gas emissions, which we are committed to control. The benchmark operational costs, hydrogen has 3 times the energy as compared, since more can cover same range, nearly 1/3 of hydrogen by weight. Grey hydrogen, which can be sold at around 250 rupees. We produce about grey hydrogen in refineries at about 150 rupees. Add 100 rupees for delivery cost, you can supply it at 250 rupees. CNG is sold at about 80 rupees a kg. Now, if you can sell hydrogen at 250 rupees a kg, even grey is affordable even today, because you will get maybe some carbon credits for the mobility sector application. Blue, if you incur some costs and use that hydrogen for fuel cells, which are more efficient, then even if the hydrogen is delivered at a cost of 350 rupees, it is affordable. Because of higher efficiency of fuel cells, you can even sell hydrogen 350 rupees, and it is affordable even today, comparable to CNG or diesel. Then the green hydrogen cost hopefully will come down, and fuel cells, etc. So carbon credits earned in blue and green will reduce costs to some extent with rollout of carbon credit and credit. So similarly, hydrogen vehicles can be more affordable with incentives if you give similar to EVs. So the question is not how many tons of green hydrogen can we produce today, at what price today, and when will the green hydrogen come at affordable level. The real question is whether we should wait for green hydrogen costs to fall, or rather strategically unlock demand and create infrastructure in parallel with its scale up, particularly in the unexplored territory of mobility. So I suggest that we have to ultimately go to green hydrogen, but the route has to be from grey to blue to green. We should simultaneously pursue this route, because you cannot, the affordable mobility you cannot have with green hydrogen at today's price. Grey makes you, possibility is there, blue with fuel cells vehicles which are more efficient. Green is the final frontier, tailored for Indian realities, because if we can produce more of renewable energy, that there's nothing like that. So I think the main conclusion is that green must remain the cornerstone for industrial decarbonization. Mobility sector offer unique opportunity for going through the various routes. Green has gas emissions, hydrogen for mobility be given similar policy support, I believe, and incentives as are being given to EVs. So if you give that, then hydrogen for mobility can become a reality, and hydrogen from gray to blue to green can be accelerated. This incentives given to hydrogen. Thank you very much.
Thank you, Dr. Malhotra, for giving a very good overview of hydrogen usage in mobility. You have very pertinently raised the topic of cost of green hydrogen and its affordability by the mobility sector. And your suggestion of way to green is via blue from the gray is very well thought of strategy for mainstreaming the hydrogen. I think in the interest of the time, let's give a big hand to Dr. R.K. Malhotra for giving a very good account of hydrogen usage in mobility sector. Now I will hand over the proceedings to my co-chair, Professor Balaraman from ISA Tirupati, to conduct the further proceedings of this session. Professor Balaraman.
Yes, so good morning, and thank you, Professor Ramakumar. And the next speaker for this session is Dr. Ashish Lille from CSIR NCL, the National Chemical Laboratory, Pune. And it's my honor to introduce him. And he's known for his fuel cell technology, hydrogen ecosystem, and advanced material. And is one of the pioneers in fuel cell technologies. Dr. Malhotra mentioned during his talk, and he's a recipient of SS Bhatnagar Award, Infosys Award, and several other national science and engineering academics. And with this brief introduction, I would like to invite Dr. Ashish Lille. And today he's going to talk on his experiences, particularly from CSIR sector, and translating hydrogen technologies from lab to market. Dr. Ashish.
Very good morning to all of you. I want to thank the organizers of this wonderful symposium for inviting me here to give this talk. I am mindful of the time. I think we have a very important event preceding this talk, and therefore I will want to keep my talk as short as possible. Can I have? Thank you. So what I will do is skip a lot of the introduction that I wanted to give and come directly to the main core. I'm going to talk about fuel cell technology and our experience in taking this technology all the way from laboratory to very, very close to market. The importance of, the messages I want to give in this talk is, of course, one that fuel cell is an important technology, and it will no doubt compete with other technologies for clean mobility and other clean stationary power production applications, including batteries, including internal combustion engines, ethanol, and so on. But eventually, I think because of the high efficiencies of fuel cell, hopefully the applications will slowly move to more and more fuel cells. That is a message that I think everybody knows, and I don't want to stress too much on that. The message that I really want to give is that in this world today, it's important for academics to take their technologies from lab close to market. How does one do it? And that's the experience that I want to share. Having done this for fuel cells and many other technologies, I think we have learned several lessons, and I want to share some of those with you today in this talk. So I'm going to skip some of these slides. Dr. Malhotra already mentioned why clean energy transition is very critical for India. The only thing I want to talk about here is the chart at the bottom right. You know, the cost of inaction, the cost of not doing the energy transition, the cost of not going green for India can be very, very large and almost unaffordable. Compared to the cost, the investments that are required in order to make the energy transition. This is a very interesting data that has recently come out, and I think it's important to note that by going business as usual is something that we cannot even economically afford in the coming years. There are many options available for India to make the energy transition, and the table on the right says that there are two particular sectors in industry. One is the industry sector at large, including chemicals, materials, and so on. And the other is heavy transportation, where we think that in these two sectors, hydrogen will play an important role as India moves more to clean energy vectors. Hydrogen is important because of its very wide applicability. It's a fantastic sector coupling agent. You can convert electrons into hydrogen, use the hydrogen for a variety of applications. And if really required, you can convert hydrogen back into electricity, although the round trip efficiency is not very great. But hydrogen as a molecule, as a reducing agent, is very widely used in India today, as Dr. Malhotra mentioned. And this is where the first important use of hydrogens will come along. I'm going to skip, as I said, some of these slides and come directly to the main core of my talk. The National Green Hydrogen Mission is a very, very important mission that the country has launched. I believe in my 30 years of experience, this is the first time I've seen that the country has taken real bets in very immature technology. The world is looking at developing green hydrogen technologies, and this is the first time that India has put a big bet on developing these technologies indigenously. So I want to commend the National Green Hydrogen Mission people in MNRE who have done this, and I think it's a fantastic document. It's a fantastic initiative of the government. In the various things that the NGHM promotes and supports, R&D is an important part of the National Green Hydrogen Mission. And for CSIR, we started into hydrogen R&D many years ago. Our journey started all the way back to 2005, about 20 years before the hydrogen is really coming to age in India. We believed that hydrogen at some point of time will become important for the country. This was 20 years ago, and we stayed with it. It's difficult in a publicly funded institution to make sure that R&D programs continue for 20 years. It's easier said than done. And therefore, I think it is an important effort that CSIR has made to make sure that we begin early and stay the course and try to de-risk our technologies and scale up our technologies as much as possible. The way we did this for fuel cells was that we formed a consortium of 3 CSIR laboratories. We came together, we brought our core competencies together, which were very complementary. And we also got industrial partners right from the beginning into the program. We used a special purpose vehicle created by CSIR called the Nimitli program to do all of these development. This whole effort for developing fuel cell technology purely indigenously happened in 3 stages. In stage 1, we actually started the whole journey in 2005. We did not even have a lab for fuel cells. We did not have people. So we made investments in people, in labs, in infrastructure, and started building small fuel cells in the lab and started to learn how to do this. At the end of stage 1, we sort of got to a point where industry became interested in what we were doing, and they started committing their own resources into the program. That's when stage 2 started, and we took the science that we had learnt in stage 1 to what we call a proof of concept. And I'll show you some of it. At the end of stage 2, we had a proof of concept that was demonstrating on the field, at least in a prototype. And in stage 3, we went to the next phase where actually the industry took over the program. They came into the leadership role, and CSR lab went into the support role. And this is where large fuel cells were built, and they were also integrated with other parts, other complex parts of the drivetrain to actually showcase a few prototypes. So this is a journey that started from lab, pure science, and has gone all the way to real products that are very close to commercialization. So in stage 1, this is where we started. We started developing small components, small area fuel cells, 10 centimeters, 40 centimeters area fuel cells. But we learned how to make bipolar plates, graphitic bipolar plates. We learned how to make milligram scale of catalyst, carbon papers, and put all of them together into a fuel cell. We produced a lot of good papers, publications, patents, PhD students. So a lot of learning ourselves happened in this area. But at the end of stage 1, which was a 5-year program, we could actually build a 0.5 kilowatt or a 1 kilowatt fuel cell. And the picture on the right that you see here is one such fuel cell, which you show that, we can light some lights there. But importantly, we developed fuel cells in all 3 laboratories. Okay, and this was a well-designed round-robin test to make sure that whatever we build is reliable, reproducible, and scalable. So the graphs that we show here are fuel cells which are tested in different laboratories. So we build a fuel cell, somebody else tests it, and it goes around. And a lot of data got generated, a lot of learnings came through that kind of round-robin exercise. And I think this kind of exercise helps the industry to build confidence that whatever is happening in the labs here is done with a purpose and is done towards taking this technology close to commercialization. Some of the examples of what we did in stage 1 are, bipolar plates that we did today. Today we can make exceptional quality bipolar plates which are fully molded. There is no machining involved. These are compressed bipolar plates with every feature of the bipolar plate molded as it comes out. And it has excellent properties. I have compared the CSR bipolar plate properties with some of the global benchmarks, and you can see that in terms of electrical resistivity or thermal conductivity, we are a little better than what is known outside. These are, of course, machinable also, but machining takes cost and time. So molding plates is much more effective. Here is another example of our own catalyst. Today, we can make catalyst at 25 or 50 gram scale, very reproducible. This is both platinum on carbon as well as platinum alloys with cobalt or nickel on carbon. And the whole lot of properties that we measure, both electrochemical properties and other properties, are shown in the table there. So developing these technologies which form the core of the fuel cell is also an integral part of the development effort. And not just the catalyst, but also converting them into an ink, finding ways to coat the ink by either slot die coaters or spray coaters, and then putting into a fuel cell and measuring the efficiencies of fuel cell, not just the IV curve, but also the durability of the fuel cell. So all of this are ways by which technologies get de-risked and industry confidence improves in these technologies. And there's always a benchmarking exercise that is done. So again, here comparison of the commercial catalyst versus the indigenous catalyst. And you can see that in practically all the properties that the catalysts are tested today, our catalysts are very, very comparable and sometimes a notch better than commercially available catalysts. This also follows with a lot of number crunching on very rigorous cost calculations. So I'm not going to read through all those numbers, of course, but I can assure you that by doing these detailed techno-economic analysis, any catalyst that we can make today in the lab, which is not just performance-wise comparable to commercial catalysts, but is also far cheaper than the commercial catalyst. This also de-risks supply chains for these core technologies in the country. This is where we ended stage 1. We entered into stage 2, and this is where the industry came to us and says, we will give you an application which we think might be useful. Why don't we try put together a larger fuel cell meant and designed for that application. This was back in 2010-11. The company that was partnering with us was Reliance. They were getting big into telecom, and they were looking at 400,000 plus telecom towers across the country, some of them in very remote areas. They would have diesel backup generators set. Reliance wanted to go green as much as possible, and they said, can we think of designing a fuel cell that would replace a DG set on a telecom tower? So this was a 3 kilowatt and a 5 kilowatt fuel cell that we did. At that time, we did not even have very easy access to fuel cell testing stations, so we actually built our own testing station. This was stationed in Reliance plant, and these are various components that you see here. You have the humidifiers, you have a lot of bipolar plate designing that was done using CFD. Stacks were put together, and you can see one of those 3 kilowatt stacks being tested on the indigenously built test bed. This is some of the data that was produced in the Reliance premises. And what I show here on the left is how we could do the scale up very successfully from a single small cell to a large 3 kilowatt stack with large area cells. You can see that the IV curve more or less is matching on top of each other. That tells us that scale up in area as well as scale up of stack is very much doable, but there's a lot of learning that came through that. These cells were also tested for long periods of time to show that they are as durable as was required for that particular application. It was actually at this point of time that we learned a rude lesson, and the lesson was that while the fuel cell actually works very nicely, we actually tested the fuel cell on a simulated tower, but the application doesn't make sense because by then the battery prices had dropped down significantly, and the problem was how do you take hydrogen all the way to remote stations, telecom towers. So it was not really the fuel cell that was a problem, it's the supply chain of hydrogen and the cost of supplying hydrogen to the towers that was clearly the problem. At that point of time, we said we are going to look at some other application. Another industry partner came to us and said, why don't we look at mobility application? We've done fuel cell for stationary, why don't we look at mobility application? This was not trivial because the performance requirements for fuel cells for a stationary applications are very different than the performance requirement for a mobility application. We needed first and foremost fuel cells which are very rugged, and secondly fuel cells which have much higher power densities. To develop those kinds of fuel cells, we had to actually go back to the drawing board. We had to get really deep into the science of how fuel cell works. And again, I'm not going to show you all these intimidating equations on the board. We actually went really back to the drawing board and understood from a modeling perspective, how is it that the fuel cell works? Because if you do not understand the science behind it, there is no way you can really improve upon the technology. So we really understood fundamentally how a fuel cell works, and the learnings from there were quite spectacular. On this chart on the top left, I'm showing you the polarization curve, what is called the IV curve of the fuel cell. The curve on the leftmost was where we were at the time where we ended our stationary fuel cell program. And through this deep understanding of how fuel cell works and further scale up and experimentation, we have been able to push the performance of the fuel cell by almost a factor of 4. We are today developing fuel cells which are almost close to 3 amps per centimeter square current density, even more than that in our recent results. We have developed exquisite catalyst by which we can allow it. And with this high power density fuel cells, we are able to condense them into smaller footprints, small enough that they can be put into mobility applications. So this is the first fuel cell car which has our fully indigenous fuel cell, which has everything indigenously built, including the catalyst that goes inside it. We then moved to a bus. This is the first, we think, India's first really and truly indigenous bus where the stack, everything except the hydrogen cylinder at that point of time was indigenously built. And this has a 40 kilowatt fuel cell aboard the bus. That's a 40 kilowatt fuel cell module that I'm showing there. We also moved from graphite bipolar plates to metal bipolar plates, which we can make here. And more recently, last year, we built a 50 kilowatt fuel cell that went into India's first fuel cell catamaran, which was launched by the Honorable Prime Minister at the Cochin shipyard. And today this catamaran runs in the Ganga. It has been tested for marine as well as inland waterway applications. It's a full drivetrain that has fuel cells, batteries, control units, DC-DC converters, every bit that is required to run the catamaran. None of this would have been possible without very, very strong support from the industry, okay? Because these are two complex technologies that no one or two or three labs can do it together. We require huge industrial support to make these kind of technologies happen. We have also parallelly done high temperature PEM fuel cell. These are fuel cells that run at 180 degrees centigrade. They can take hydrogen which is impure. You can also run these fuel cells with as much as 1 to 2% carbon monoxide, which is a poison for low temperature fuel cells. Here again, the entire supply chain, the membranes, the bipolar plates, the carbon paper, everything has been developed within CSIR. Today, we are able to put together a kilowatt scale high temperature PEM fuel cells. These are some of the performance data for the high temperature PEM fuel cells. And we have an interesting company partner now who's looking at developing drones based on these kinds of fuel cells. That's a program that is underway. But today we can make, therefore, both high and low temperature PEM fuel cells. At the end, I'm just closing my presentation by showing another interesting experiment that we are launching. Hopefully very soon we will launch the Pune Hydrogen Valley Innovation Cluster. In this program, we are looking at all parts of the hydrogen value chain: hydrogen production, storage, distribution, and utilization of the hydrogen. There are two important novelties here. First, we are making hydrogen by a very different route. We are using bioethanol. In a single step catalytic process, we can convert bioethanol into ethyl acetate with hydrogen coming out as a byproduct. So we have two value streams. Ethyl acetate is widely used as a solvent, and hydrogen, of course, is used in many different applications. The second novelty in this valley is the use case of hydrogen. We are looking at using hydrogen in fine and specialty chemical sector. This is a very important sector for India. This sector produces pharmaceuticals, agrochemicals, dyes and pigments, colorants, fragrances, and so on. About 15 to 18,000 small and large companies operate in India in this sector. Many of them use hydrogen as a feedstock. Today they are using hydrogen which is gray hydrogen. Many of their products are sold outside India, and therefore if they move from gray to green, they get carbon credits in markets outside India, where it is today possible to get carbon credits. And therefore it makes perfect sense for them to move from gray hydrogen to green hydrogen. Now, if that hydrogen comes at a price point which is very close to gray hydrogen, it makes imminent sense for this sector to quickly move from gray hydrogen to green hydrogen. And that is what we are trying to do with this interesting technology of converting bioethanol into hydrogen with ethyl acetate as a byproduct. Both hydrogen and ethyl acetate are widely used in exactly the same fine and specialty chemical segment. So if we have the hydrogen valley set up, this bioethanol production set up into a cluster where there is already a lot of chemical industries sitting there, and there are many such clusters. Hyderabad has a pharma capital of the country. We have sectors, we have regions in Ankleshwar, Panoli, Dahej, many places in Maharashtra where there are already clusters of chemical industries. If you put an hydrogen manufacturing plant, which also makes ethyl acetate, you can sell this within 50 or 100 kilometer radius. And therefore, it's a very interesting experiment that we are planning to embark on, and hopefully we will get there pretty soon. These are some cost numbers for what is the cost of that hydrogen, and you can see that for the bioethanol cost, that is the market price today, the landed price of bioethanol today, and the ethyl acetate market price today, we can actually produce hydrogen at as low as 240 to 250 rupees a kg, about 100 rupees less than the electrolyzer cost. So this looks like an interesting technology. Of course, every technology has its limitation. This technology also has its limitations, which I can talk to somebody who is interested in it. But we are looking at this completely Indian innovation, very new, first to the world kind of innovation for making hydrogen by a very different route and using it also in a very different sector. So with that, I will close, and I hope I have kept my time. Thank you very much for your time.
Thank you, Dr. Ashish, for your wonderful overview and success story about fuel cell technologies, completely based on indigenous strategies, both catalyst development as well as their application point of view. And starting from academic research, and then proof of concept, prototype, and finally you have reached a real world application. So wonderful, highly commendable. And also that latter part, bioethanol to green hydrogen also. So excellent overview, good. And CSR contribution to hydrogen mission is highly commendable. Okay. So we are not going to take any questions from the audience. So tickets are available. We can interact with during the tea session. Now we'll move on to the third speaker of this session. So now it's my pleasure to introduce Professor Muthukumar, thermal engineering from IIT Tirupati. And Professor Muthukumar completed his PhD from IIT Madras and is a recipient of Abdul Kalam Technology Innovation Award. And prior to his position at IIT Tirupati, he was a professor at IIT Guwahati and is very well known for his advanced clean energy technologies. So with this brief introduction, I would like to invite Professor Muthukumar for his delivering talk on design, development, and testing a large-scale solid-state hydrogen storage.
Okay, so good morning, everyone. First, I'd like to express my sincere thanks to the organizer for providing this opportunity to share our knowledge, our research activities on this solid-state hydrogen storage and purification and compression system, which we have carried out at IIT Guwahati and as well as IIT Tirupati. I was at IIT Guwahati for about 17 years, and a few years back I moved to IIT Tirupati. The previous, the previous speakers, of course, talked more about hydrogen in general and majorly on hydrogen generation and other utilization part. Here, in this talk, I'm going to discuss more specifically about the storage of hydrogen and then purification and other application which is associated with thermal management, all these things. Most of you are aware about these sustainable development goals. So all 17 goals are associated with the energy, maybe directly or indirectly. If you see the goal number 12 and 13 and 7, they are directly related to energy. So when you talk about clean and green hydrogen, again, it need to be produced from the renewables. When you produce hydrogen from the renewables, hydrogen is acting as an energy carrier for transforming energy from the source to the user. And during this, it's like kind of electricity. And so during this, the life cycle, if you see the life cycle, the cycle starts from water and ends with water. And only the hydrogen is acting as an energy carrier, for transforming the energy available from the renewable, to the user point. So if you look into the decarbonization cycle, and hydrogen completes the decarbonization cycles. And when you come to the energy content, of course, it's almost 3.5 times higher than the conventional fuel. And so when you talk about the hydrogen-based energy economy, we need to concentrate in 4 major sectors, starting from hydrogen production and storage and transport and utilization. So we have enough and mature technology in a utilization point of view. And production also, of course, we more or less we reached the point where we want. But where we lack is the storage and transportation. So if you look into the available technology, whether if you want to go for the pressurized form, where people are talking about type 3 and now type 4, type 3 and type 4, now type 5 tanks have come. And of course, there are few companies started in India to manufacture this type 3 and type 4 tanks, but we don't have the testing facilities. And of course, now through the government project, few startups are trying to make the facilities for testing the hydrogen, for testing the type 4 and type 5 cylinder. But nevertheless, if you see the energy requirement to compress the hydrogen, say from 1 atmospheric pressure up to about 700 per pressure, which is very high, in the order of about 20%. Then when you come to the liquid hydrogen, again the liquid hydrogen also, I mean, if you see the several stage, it's a kind of a extensive process, energy extensive process. Overall, the energy consumption, if you see, nearly about 40%. Again, retaining the liquid stage for a longer period of time is a challenge. So therefore, we need to look for the other alternative solution where hydrogen can be stored at atmospheric condition and maybe for longer duration and with minimal energy consumption. So if you look into all the aspects, the metal hydride, that is the solid state based hydrogen technology, and as course attention. So here, we use the several intermetallic compounds. They can be produced either by milling or ball milling, melting route. When you expose this intermetallic compound at certain pressure and temperature, and they absorb hydrogen, and this absorption of course takes place in several stages. Once the hydrogen is absorbed by this metal hydride, hydrogen will be stored in the form of solid. So that's why it is called as a solid state storage. Then when you want to get out the hydrogen, when you want to discharge hydrogen from the system, you have to heat this, heat the system. So basically, the absorption is exothermic in nature. That is, heat will be released during absorption of hydrogen by the metal hydride, and during desorption, you have to supply the heat. So by choosing the proper operating temperature and pressure, and we can construct several thermal management application, including hydrogen, maybe the heating and cooling and heat transformer and hydrogen compressor. Many such application can be possible. And at both the institute, IIT Guwahati and IIT Tirupati, and we developed many such systems, and some of the system being, of course, transferred to the industry for the commercialization. And if you look into the system, and most of the system will be like kind of a heat exchanger, and you can see here, and there will be a lot of cooling tubes required for thermal, for you can say the good thermal management. As I already mentioned, when you charge the hydrogen to the system, it undergoes the exothermic reaction where you need to remove the heat. And when you want to discharge hydrogen from the system, you have to supply the heat. So therefore, the thermal management is the crucial aspect. For all this system, first you have to optimize the heat and mass transfer characteristics of the reactor. And then based on the heat and mass transfer characteristics, and you can arrive the optimum configuration of the reactors. Then you can do the kind of simulation studies, identify the optimum operating parameters, then you can fabricate the system, then you can do them in real scale testing, and then you can take it for several applications. In both the institute, we have developed several such systems, right from 1 kg alloy capacity up to about 100 kg. And now we are in the pre-industrial scale development. Recently, we got the big project from DST where we are going to develop the 100 kg hydrogen storage system for the the mining vehicles, and as well as we are also going to build about 200 kg system for purification application. So we have made several such prototypes and it's being tested at various operating conditions. Most of these informations are available in the open literatures. And by fine-tuning the system performance, and we can arrive the best operating condition at which you can get the better the performance in terms of absorption time, desorption times. Everything can be fine-tuned. So based on your requirement, system performance can be fine-tuned just by varying the temperature and pressure. And we have also developed the for example when you go for when you make this kind of system for hydrogen storage, during desorption, you will be getting cooling effect, which is kind of a complement for you. For example, if you design the system for fuel cell application, and during discharge, when you consume the hydrogen from the, when you when you discharge hydrogen from the system, you will get the cooling effect. For example, you can see here, these are the two prototypes, which can deliver nearly about 5 to 7 kilowatts of cooling, in addition to providing about 700 grams of hydrogen, and you can also get about 5 to 7 kilowatts of cooling. And this is the another kind of a design, where the previous design we had so many kind of your tubes, nearly about 200, 300 tubes. And after making a system and during the testing, if we find any one of these tubes leaking, the entire system will be waste. So therefore, we made this kind of your tube bundle reactors with this tube bundle reactor, each tubes act as individual reactor, even if anyone fails during the testing, and we can isolate them, and so that the main system cannot be affected. So we made such kind of system, and for the large capacity application, and they were tested for, for several applications. You can see here the setup, and then this is again the large scale system, and it's meant for, this kind of system. Now we are going to integrate with the the mining vehicles. And in fact, now we are planning to develop the hydrogen-based, the engine for the, these mining vehicles. And we got a big project, and this engine will be operated with, you can say blended with the CNG and as well as the gasoline. This work, it's going on now. So where this kind of reactor will be integrated with the mining vehicles. The mining vehicle weight is not a problem. In fact, they need more weight. And this is another class of the reactor. For example, if you take the magnesium-based hydride, which can be used for thermal management application, where you can store the heat in the order of about 300 to 500 degrees Celsius. And when you go for higher operating temperature around 500 degrees Celsius, suddenly we have restriction in using liquid as a heat transfer fluid. For such scenario, we have developed such kind of a configuration with the novel reactor where we can use air as a heat transfer fluid. This is the first time we have developed, and this was tested, and we got a significant performance. Now we are going for such kind of a modular reactor design for the stationary application as well as the these mining vehicles. Yeah, this all we have tested, and we have done extensive studies in thermal management. As I already mentioned, so for a given capacity, if you want to have fast charging and fast discharging, you have to play around with the thermal management, which is very crucial. So we developed several such novel configuration, and so based on the thermal modeling, we have optimized the the configuration. So when you go for such kind of reactor design, the thermal mass, that is the empty thermal mass, that is a crucial thing. The ratio of the reactor weight divided by the empty thermal mass. This ratio we need to optimize. Okay, it should be as high as possible. So therefore, we evolved several reactor design, and you can see here among all the you can say the reactors design reported across the world, our designs performance much better than the one reported in the literature. This allows our recent development, and so certainly all this configuration will go for the application which I have mentioned earlier. And so this kind of application, we are planning to use it for hydrogen purification as well as the cooling system. And so it's already done. So another interesting application is this also we have explored the cooling for the automobile. This reactor we have made. And for example, see here, this is such a small reactor, which is maybe the volume is less than a liter. And you can see here, when you start disarming the hydrogen, within few seconds, maybe about 15 seconds, you can see the formation of ice over the reactor. So then you can imagine the rate at which the cooling will be produced. So with this small kind of prototype, we evolved, and we found the COP in the order of about 3.5. And this is a smaller system. And by gaining the experience from the smaller system, we built the bigger system of having capacity about 10 kilowatt. You can see here, these systems were tested, and we got interesting performance. And the only thing is, we don't have the kind of a dedicated compressor which can be used for hydrogen. What we got used the compressor which is developed for R134A with some retrofitting. Now we are in touch with some company and who can develop us for this dedicated compressor. Maybe once we get the dedicated compressor, and we can get the COP as close as 4.5. And the another interesting application is the hydrogen purification. So other than electrolysis process, if you produce hydrogen from any of the reforming or the natural gas reforming, methane reforming, or anything, biomass gasification, you won't get 100% pure hydrogen, where the purity will be in the range of about 40 to maximum about 60%. So now currently we use the PSA, pressure swing adsorption, or membrane separation process, or few process. Each one is having its own limits. Suddenly you cannot get 99.99% purity. So there is a one. So using this technology, even if you have purity level of 20%, you can get 99.99% purity. So this is very special here. So the metal hydride, what happens, it takes, when you supply hydrogen along with impurities, metal hydride takes only pure hydrogen. Remaining impurities sits in the void space. Once it is absorbed, then what happens, all hydrogen goes into the metal lattice, remaining impurities will sit in the void space. Then after absorption, just you open the valve and flush out the system, all impurities will come out. Then after that, what remains inside the system is 100% pure hydrogen. So with this, we have developed the 3-stage purification system. We varied the impurities of the CO, CO2, nitrogen, and even methane, argon, and the other gases. And we different combination we have taken. And finally, we could get the purity in the range of about 99.9%. And this technology was transferred to NTPC further, we integrated this reactor with the generator, where in the generator, they need to maintain the hydrogen purity of about 97%. So this was integrated, it was successfully tested. And so this is the 3-stage system. In the 3-stage system, suppose if the purity is above 90%, then you can activate only one stage. Suppose if the purity is in the order of about 60 to 70%, then you can go for 2-stage. Suppose your purity is less than 60%, say 20%. In that case, you can go for all 3 stages. At the end of the 3rd stage, you will get 100% pure hydrogen. So all these things we have extensively we have done. And of course, the several patents also emerged from this technology. And again, from this technology, you can also generate simultaneous heating and cooling. And also, you can also upgrade the thermal output. For example, if you give heat maybe at about 300 degrees Celsius, using our technology, you can upgrade the heat input, say, from 300 to 400 degrees Celsius. At the same time, you can also generate cooling at about minus 10 degrees Celsius. That is possible. This is called polygeneration. Such prototype also we have tested, and now we are planning for the higher scale. And the another one is the compressor. For example, in case of electrolysis, even if you go for the alkaline-based electrolysis or any electrolysis, maximum you will get about 10 to 15 bar pressure. So when you go for pressurized storage, maybe if you take a Type 4 cylinder, you need to compress up to about 1,000 bar. Then only you can store it in the Type 4 cylinder. So such compressors are reaching about 1,000 bar pressure is not so easy. We need a multi-stage compressor. These compressors are very expensive, and lubrication is the another challenge. And there are several issues associated with the mechanical compressor. So using this metal hydride technology, you can take hydrogen maybe at about 2 bar pressure, and make it absorb maybe at about 25 degrees Celsius. Just to heat the reactor, say from 25 degrees Celsius up to about 80 degrees Celsius. Then the pressure will build up inside the system. With a single stage, you can reach maybe about 70 or 80 bar pressure. Then after that, you connect to the another 2nd stage reactor, where it can take about hydrogen at about 70 bar at 25 degrees Celsius and heat to the same temperature limit of about 80 degrees Celsius. Then it will pressurize up to about 200 bar. Then with the 3rd stage, with the same temperature limit, you can achieve up to about 600, 700 bar. So such system, in fact, first time in the world we have developed such system, and this was tested. And with about 80 degrees Celsius, we could reach nearly about, with 45 degrees Celsius, we could reach around 170 bar, since we don't have facility to go beyond 160 bar at laboratory level. But with the closed loop, we demonstrated up to about 450 bar just by heating the system around 80 degrees Celsius. So when you go around 150 degrees Celsius, this reactor can reach easily around 800 bar. So these reactors are designed to handle up to about 1,400 bar. Since we don't have the permission to go for high test, we restricted ourselves with 300 bar. So this is the test, and the technology is already transferred to NTPC. So this was the kind of a roadmap now. Ultimately, maybe by 2030, our government is planning to launch hydrogen as a kind of a automotive fuel. This may come in both the fuel cell route as well as the direct hydrogen ignition engine. Several such program is being initiated. And the hydrogen is also will act as a large-scale electricity storage. So now India is going in a big way in renewables, and so when you go in a big way in renewables, again the renewables are not reliable. So for instance, if you consider the solar PV, you will get only the generation during the daytime. Then what will you do the nighttime? So when you want to store gigawatts amount of energy, electrical energy, we cannot employ batteries. Batteries, again, it's again big questions. So in such scenario, you can go for hydrogen. Whenever you have excess electricity, you can generate hydrogen from the excess electricity, and the hydrogen can be injected to the national gas grid, or it can be injected to the this dispensing station for the automobile application. So now the government is planning to use hydrogen as a cooking fuel, and we have taken up these activities for developing hydrogen burner at IIT Tirupati, and in combining with CNG. And many such things are happening. Just I wanted to highlight about our national mission. Maybe probably the previous speaker might have highlighted the national hydrogen mission, where we are planning to produce about 5 million metric tons of hydrogen by about 2030 at a cost of $2 per kg. Even the previous speaker mentioned, even if you produce hydrogen at about $4 per kg, still it is economical and it will be more reliable. And very soon the hydrogen is going to, you can find hydrogen everywhere, not only in domestic sector, but also in industry. Now the steel industry is keen on pushing green steel production. Ceramic industry is exploring, the use of hydrogen for the drying application. Even the cement industry and pharmaceutical industry and many more industries are, of course, now looking forward to use hydrogen as a feedstock or a fuel or a energy carrier. So with this thing, once again, I thank the organizer for providing this opportunity. So if you have any queries or questions, maybe probably I can take up in a couple of questions. Thank you. So hope I have done in 20 minutes. Yeah.
So thank you, Professor Muthukumar, for your excellent research work on metal hydride based hydrogen technologies and also reactor design or purification of hydrogen. Excellent. And now it's my duty to request Dr. Ramaprabhu to hand over your memento to Professor Muthukumar. Muthukumar, please. Yes. Thank you, Doctor. And now we have come to the end of this session. And this section had 3 speakers. First, we started with Dr. Malhotra, gave an overview about hydrogen e-mobility, and followed by Dr. Hashish Lille, Director NCL Pune. I gave an excellent success story about fuel cell technology from the context of hydrogen application. And then third speaker, Professor Muthukumar from IIT Tirupati, talked about hydrogen storage technology, like a mobility, application, and storage. All these 3 components in the hydrogen mission is nicely covered. And let's give a big round of applause for all these 3 speakers. Yes, now we'll break for high tea. Thank you for this opportunity.
Now I invite Dr. Balaraman from IISER Tirupati to felicitate Dr. SSV Ramakumar, Chief Technology Officer, AM Green. So kindly felicitate. The much awaited moment is here. Kindly please be seated as we are looking forward for the arrival of the Honorable Chief Minister of Andhra Pradesh, Sri Nara Chandrababu Naidu Garu. Kindly refrain from roaming around or going outside. For security reasons, it would be really very difficult for people to take control. Yeah.
University AP is a multidisciplinary research intrinsic university. Backed by a 60-year-old legacy that is transforming the face of education, technology and innovation, SRM AP stands as a pioneer in educational excellence. Spread across 100 acres and designed by the American architectural firm Perkins & Will, this new age university believes in being globally connected, regionally transformative and nationally relevant. Established in 2017, this tertiary educational institution is home to over 9,000 students from across India and 38+ countries across the globe. SRM University AP, known for its forward-thinking curricula, interactive learning methodologies, and industry-oriented programs, help nurture students not just as scholars, but also as visionary leaders and change-makers. With 19 departments across diverse disciplines, we don't just educate, we redefine learning. The three schools, School of Engineering and Sciences, the Pari School of Business and the Iswari School of Liberal Arts, are carving excellence in their respective domains. SRM AP School of Engineering and Sciences, SEAS, is one of the most sought-after schools, on par with the country's top engineering institutes. In a landmark collaboration with Carnegie Mellon University, SRM AP has established an AI institute, marking a bold step towards global leadership in intelligent technologies and future-ready research. Pari School of Business, SRM AP's management precinct, is known for its global collaborations, innovative pedagogy, and entrepreneurial mindset. The Ishwari School of Liberal Arts, SRM AP's Liberal Arts School, is synonymous with progressive thought and an interdisciplinary approach. With a spectrum of world-class resources in terms of research, academic, sports and extracurriculars, SRM AP has become a center for holistic education. The university also has a dynamic team of faculty, a full-fledged entrepreneurial ecosystem and global partnerships, making it an institution of repute. The varsity's strategic direction is guided by top leaders and educationists from the University of California, New York University, University of South Florida, and McGill University, Canada, to name a few.
I would love to see SRM is counted among the top 10 universities of India, and I would love to see it as the #1 private university in India. I think we are making good progress, and hopefully we'll achieve that.
SRM AP will be a strong and contributing component of this region's economy. And I don't just mean financial economy, I mean intellectual economy and entrepreneurial economy. And SRM AP will be a major contributor to that. But I know the leadership here has ambitions far beyond that SRM AP will become a major contributor to India, and indeed a major contributor, a major contributor to the world. And I have every confidence that those ambitions will be achieved.
SRM AP, in large part because of its commitment to become a comprehensive liberal arts as well as interdisciplinary university. And I have been, very pleased to see that it's continued to honor that commitment in the way in which it's been building and growing.
The university's students have also made a mark in the sporting world, with Olympians, Paralympians, and other international athletes representing India on a global platform. SRM AP proves that it not only believes in pure academic excellence but promotes holistic growth as well. Our alumni network is second to none. With graduates placed in Fortune 500 companies and some of the top-ranking universities of the world, SRM AP graduates leave an indelible mark, carrying the legacy of the SRM brand across countries and continents. At SRM AP, every milestone is a leap to a vibrant tomorrow.
Welcome to SRM University AP, where innovation meets excellence. Nestled in a beautifully designed campus by the renowned Perkins & Will, SRM AP stands as a beacon of advanced learning and holistic development. At SRM AP, learning transcends the traditional. It's an interactive experience, a blend of global perspectives and cultural diversity. Here, research isn't just important, it's a way of life, pushing the boundaries of innovation and discovery.
share. we want to set up innovation center here at SRM AP for hydrogen technologies. In the next 2 years, we assure and commit to the Honorable Chief Minister that we will develop a hydrogen power car between Vijayawada and Visakhapatnam with refueling facilities along the way. Also, this university proposes, and as you directed us on 11th March, to develop a hydrogen powered train between Hyderabad and Visakhapatnam where hydrogen is available. These two things we would like to do with the kind support of the Government of Andhra Pradesh, the industry present here, and Ministry of Railways. Now I request Dr. Satyanarayanan to speak, then we will go to Pranav Tanti.
First of all, I would like to welcome the Chief Minister, the Honorable Chief Minister, for this Hydrogen Summit. And I understand he's been away from Andhra Pradesh for the past 3-4 days, and he's very tired. But in spite of that, he has made it to this occasion. We are very happy to be hosting this event. As Professor Raut told, we will be interested in producing hydrogen in the university. But for the industry, and also we would be interested in doing a prototype for a hydrogen train which can run between Vijayawada and the Visakhapatnam. So I request our Chief Minister, who has always been readily helpful for us, to help in this initiative also. Thank you very much.
Must be ahead of times. Okay, now I'm very happy to come this interaction session. After that, inaugural session will be there. 2 days, all of you are going to be here to finalize the agenda. Green Hydrogen Summit 2025. I welcome all of you. I want to hear from you now. We are taking all initiatives, how to go about brief introduction of the subject. Then we'll go to main meeting. I am assuring you, what all you bring new ideas and innovations. We are here to execute and produce proof of concept in a big way. That will be replicated nationally and globally. And also we will follow wherever there is a best practice or innovation, as it is, we will adopt it. We will work plus on that. That is our intention. I am very happy. Now we can interact.
Sir, now I request Pranav Tanti, CEO and President of Switzerland Group, and they are very keen to invest for production of green hydrogen. I had a brief discussion with Pranav Tanti. They want to produce 40,000 tons of green hydrogen in Andhra Pradesh, provided the Honorable Chief Minister will provide necessary facilities. So now I request Pranav Tanti.
Respected sir, other dignitaries, thank you so much for this opportunity. So I'll just spread a different version of Synergen, which is our company. Suzlon is obviously a wind turbine manufacturing company. Synergen is in the green molecules, green fuels. We have currently advanced stage development in Texas, Houston. 40,000 tons of hydrogen capacity and 200,000 tons of ammonia, green ammonia. It's an integrated plant. We have 250 megawatts of behind-the-meter solar and 500 megawatts of wind integrated with the grid. So this facility, it seems simple, But the biggest challenge that we have seen in the last 4 years of working on this thing is the aspects of commercialization. Right? It's various moving pieces. The typical pieces have been the land, water, and power. These three pieces needs to be very critically aligned, very close to the port to make sure that the larger production actually is for an export market. The good quantum can be for the domestic market also. So the hydrogen piece is for the domestic, the larger component is for the export. So we are looking at a similar facility in India, in Andhra specifically, and we are exploring a lot of ports on the coast of Andhra. State has been blessed with several resources, blessed with the beautiful coastline, and I think that's where development of a lot of these ports, which your visions have been in a long-term visions, has been very important for us. So we will definitely commit. We are committing right now also 40,000 tons as a starting capacity, but going forward, a similar size can be double, tripled within the state.
Now I request Dr. Saraswat, Honorable Member of Niti Aayog, who is an author of, rather one of the authors of National Hydrogen Mission. Dr. Saraswat Saab.
Sir, very good morning. I think I am okay. Are you good? Very good morning. I am audible? Yes, sir. I am very happy to be present in this summit today. The National Green Hydrogen Mission, which has been announced in 2023 by our Honorable Prime Minister at a cost of 19,500 crores, it stipulates certain major objectives. And one of them is that India should have 5 million tons of green hydrogen by 2030. And also there is a requirement that we should have 3 hydrogen valleys that should get formed. And the idea is Valley 1, Valley 2, Valley 3 will go from 5 million tons to 550 million tons and then 500 million tons. The purpose of this valley is not just to kind of production alone, but it is to create a complete ecosystem for that. All of us know that green hydrogen will become affordable only if we are able to bring down the cost of the electrolyzers. And the power is becoming more and more cheaper as well as cleaner. So already fortunately the renewable power in the country has come down to very low cost, and so there is no problem. But the problem of electrolyzer is still a problem. I personally believe that in Andhra Pradesh we have the right ecosystem, and one of the hydrogen valleys should be located here. And what we should do here is that with the help of many of our industry partners who are here today, we should set up a large scale electrolyzer plant. And Dr. Narayan Rao mentioned that they have a technology. Yes. Certainly we can take that technology or beyond or any other technology.
Yes, yes.
From the government of Andhra Pradesh. Sir, I request Dr. R.K. Malhotra, President of Hydrogen Association of India. He has rich and vast experience in the energy sector. Presently is the senior advisor to the Minister of Petroleum, MNRE and many agencies. Now I request Dr. Malhotra.
Good afternoon, sir. It's a privilege to be in this meeting with you. You are known as a very progressive Chief Minister of the country. We have seen the kind of progress you made here, and now when you build up the new capital, I think hydrogen should be the focus area. AM Green is doing a good job. Suzlon wants to do big projects. But as Dr. Saraswat mentioned, that you have Visakhapatnam refinery also, and where the hydrogen can be produced, blue hydrogen can also be delivered. So a mix initially, as long as the hydrogen, green hydrogen cost is higher, for various applications there will be some reluctance. So mix of blue and green, if it is used, you can become the, maybe when you build up the new capital like Amravati, you should have hydrogen buses plying, which can run. Initially, the cost will be higher with green, so initially you can start with the gray hydrogen or blue hydrogen, and then, color agnostic approach, and demonstrate the fuel cell buses, which Dr. Ashish Lele there, 2 times more energy efficient as compared to the internal combustion engines. So overall energy consumption will come down. Second suggestion which I would like to make is that maybe you can adopt some villages where you can have localized distributed power generation. You can have solar power to generate electricity, then you can have villages using that power during the day for cooking maybe, or converting into hydrogen, and then hydrogen stoves also. Scotland is a country where a lot of, developments on cooking stove applications. So villages can use that hydrogen, maybe in tractors also, maybe for irrigation pumps. So that kind of approach also, daytime you can use solar energy, store it in the extra solar energy can be stored in the form of hydrogen, and then it can be used. So maybe these are some of the suggestions. From hydrogen association side, we have been supporting and educating people on various kind of activities related to hydrogen. We'll be very happy to work for Andhra government also if any proposal is required or any support is required from Congress.
What is the cost difference between hydrogen storage and also battery versus to pumped storage?
So that cost difference between pump storage and hydrogen storage in different forms, because if you have to have
No, I can understand it is a conversion.
Yes.
I can understand. Now,
so
as
hydrogen
on
storage,
today,
pump storage will be much cheaper.
We are all working as on today.
Yes. Much cheaper.
So to say, even if you take the best chemistry battery.
So only temporary, immediate, how to solve the problem, we are going for battery. Even there will be some more innovations in battery, then it will help. Meanwhile, it will come.
The hydrogen storage.
Hydrogen storage, that is another area. Replication and scaling will be a problem. How to act all these things, that is where I want to learn. In this country, all of you have to remember one thing. All innovations I started, first of all, power sector reforms, nobody ventured to attempt. That is late 90s. Saraswati is aware of all those things. I started power sector reforms. Because of power sector reforms, I lost power also. That is different in 2004. That is another scenario. But always that was a benchmark today. And also all states are forced to adopt power sector reforms today. So these are all, I am aware of all developments in power sector, not today, from the historical past also, from inception, especially 1995. So I'm analyzing all our ideas and thoughts and innovations, how to integrate, how to take logical conclusion.
Sir, now I request.
Sir, as far as storage, as you said, I think battery storage, whatever time it happens, will always be a costlier option as compared to the pump storage option. Because pump storage will run on the solar power or wind power, and rest of the, both the capex and the opex are very, very small. You know, today itself, if you take solar power, pure solar power without storage, it's about less than 2 rupees. But the moment you add the battery, it becomes 5 rupees. So that is the kind of scale. Even if you reduce the cost of battery, which is most unlikely because battery uses all critical minerals. And these critical mineral costs cannot come down because of non-availability. So marginal changes will come. So we have to always explore methods of storing hydrogen or storing power using the other methods. For example, hydrogen storage you can use as Sir Ramkumar is telling ammonia. People are using ammonia, people are using ethanol, people are using methanol. They are the best carrier of hydrogen. They can be carried and then they can be reformed to give you pure hydrogen. And once that has happened, your transportation cost comes down, your ultimately delivery cost of hydrogen to the end user becomes the cheapest if you follow that. So storage, I personally believe we should focus on cheaper means like pump storage. That is the best method is going to happen.
Yeah. Sir, now I request Andrew Schumann, CEO, Everensis Renewables from Australia.
Thank you very much. Thank you for the opportunity to come and speak to yourself and everybody here today. I'd like to bring a little bit of a different perspective to the conversation, and that's the one of an investor. Unless we can really make green hydrogen a value proposition, then it's going to be very difficult to get the investment. And without substantial investment, it's going to be hard to be successful. So a bit about myself. I'm an engineer. I've spent a large portion of my life working with doctors and professors, helping them to build process plants and processes and then upscaling them to commercial scales. And so I appreciate the complexities behind that. And I was really happy when Seshidhar approached me to join Arvensis. The Arvensis group is looking to invest in excess of $100 million into India. And we're looking at areas such as technology, AI, 3D printing, and all those things. We're also looking at renewable energies, and we're also looking at e-waste recycling. And we've been really, really impressed with the vision that I've seen in India. You know, when I've looked at all of the documents and the research that I've done, the vision that the government as a whole, as national, and then yourself has really put forward to say, this is where India wants to go. I really wish that Australia would have that same vision and be so clear about it. People are very scared to commit to any technology, whereas you have been very, very good with that. And so for me, from an investor perspective, you know, we're going to be starting off. We're working with to get permission from NREDCap to start our first 12-ton per day biogas plant, and we plan to rapidly expand that to 50 tons per day. Obviously.
Okay, please go ahead. Yeah. Okay, please go ahead.
Oh, okay. So we're going to be rapidly upscaling that to 50 tons per day. And we've always been looking at, rather than just staying at biogas, how do we extend that into green hydrogen? So I've started doing quite a bit of research into, you know, how do we de-risk this from an investor perspective? What are the things that we need to do to ensure that the demand side is there? And it was really good for me to hear the esteemed doctors all around the table all saying we need the demand side to get there. We need to get other applications other than just the fertilizer industry and the petroleum enrichment industries. We need to look at how do we actually increase the demand, and then on the other side, how do we look at the supply? Now, being a biogas provider or investor in that, I feel a little bit, like the orphan child. If I look at the scheme that's been put in place for the development of green biogas, it's all about electrolysis. Okay? And the generation of green hydrogen from the biomass itself is really relegated to projects and research sort of initiatives. And so I would really ask, those are the two things that we would like to participate and understand. How can we help increase the demand side of the equation, and at the same time work with you to de-risk the supply and the technology that's actually used on a biomass?
Before we close this session, I request the to address the stage.
Friends, only I came here to learn more and also adopt all those new technologies, new innovations, ultimately how to reduce the cost of energy. Second angle, because of global warming, how to go for green energy. Once green energy, then time towards downstream industries. Storage, ammonia, ethanol, so many innovative ideas. So I'm very happy to listen all of you. 2 days you are going to be here. We are having a clear policy. Even our Prime Minister is working in a big way. 500 gigawatt capacity on green energy. That is this mission with the downstream product also. What all you recommend, and then we'll start working in that direction. I'm very happy as a planning Niti Aayog member has rightly mentioned, Andhra Pradesh will be hydrogen valley. I'm assuring you that it will happen. Towards that, how to bring all technologies for convergence and innovations for convergence. Both will work it out. Every year, if necessary, we'll review our performance also from now onwards. Benchmarking, where are we? Next year, what is the target? Then how to move forward. You want to do any experiments, best place is Andhra Pradesh. I'm assuring you, you test all our R&D research here. And then we'll implement any innovation. You need proof of concept. Otherwise, it is only innovation. That proof of concept we'll produce here and we'll scale it up. We'll take nationally, globally, wherever it is having demand. So I'm very happy for that today, because there is a seminar also. We'll go there. After that, we will have discussions. After 2 days discussions, what all you recommended, my chief secretary is looking after energy. He is also having long standing in energy department. I think is the senior most energy secretary in the country. He is the senior most. So I'm very happy to associate with you. We'll work together. Thank you.
We are very much grateful to the Honorable Chief Minister for having this discussion with representatives of industry and R&D organizations. Thank you, sir. We'll come back to the government with the recommendations we submit.
Check 1, 2. Mic test 1. Check 1, 2, 3. Test 1, 2.
We put it in a gasifier, it generates a syngas, carbon monoxide and hydrogen, and that requires our green hydrogen electrolyzer. We attach extra hydrogen and we ferment the syngas using our fermentation technology and we make an ethanol, sir. So in this process, the complete waste will actually convert into ethanol. So typically 1 ton of any biomass, like bagasse or anything, it is very 2,000, 3,000 rupees worth. But we can convert into 1,200 liters of ethanol.
Yeah.
So 1 liter of ethanol is costing 71 rupees. So it's a very value addition. So from the agricultural rice point of view, every farmer will get huge amount of margin, not only from the crop, from the waste. So this is the whole project, sir. We want to propose for the.
Good.
Thank you.
We will work it out.
From AP Industries.
Sir, we given a proposal for a green fuel station as well as excellence center in Amravati. Sir, already taken up.
They want to start a global excellence center at Amravati. Last time we will be getting it to next cabinet.
Hydrogen also we are likely to produce, sir.
We will work it out.
KP
We will very happy.
major at Gujarat, sir.
We met you, sir. Farooq Patel ji came and.
Acha. Yeah, I remember.
CSR funds they want to.
Now we will work it out.
First they said they will give CSR and they want to develop excellence center, training center. Then they want to come to
Blue and green hydrogen manufacturing plant we want to do, sir, and fuel station also, sir. If Amravati think about complete green hydrogen, we have a fuel station which we shown you. One EV station, that is also green EV station, as well as one green hydrogen hub will be there. You can declare that entire Amravati should only run on a hydrogen or EV. That sort of a thing we can definitely.
Now we will work it out, that ecosystem.
Thank you, sir.
Hello.
This is the project, sir. Meere sanction చేశారు 2018
Yeah, I remember.
This is a reality, sir, now.
No, I remember.
Because power is getting withdrawn from here already. And this is the Kakinada project, which is.
This is
getting
the
refurbished
Nagarjuna.
ammonia. ముందు phase 1లో 500,000 tons, సార్. ఆ తర్వాత 28 కల్లా full 1 million ton. I think countryలోనే we are the number 1, sir.
83 we brought Nagarjuna. Now you are converting.
Pankaj Patak wants to explain recycling of e-waste.
Sir, we are having a different approach of recycling the e-waste through hydrometallurgical process. So right now we have developed a technology which is going to be for upscaling this thing TRL5, where we are having the cathode material and we are having a selectivity of the metal like lithium, cobalt, nickel, manganese. We can select it later, and later on we can make up for the battery manufacturing. So we have made the precursor and that can be used for the battery manufacturing. So these are the things we are having it, and also we are going to run for the pilot scale.
Okay, very nice.
Now we'll go for inauguration.
Yeah.
Minister Shri Nara Chandrababu Naidu Garu, a visionary leader, a pioneering force in modern governance, and a leader whose unwavering commitment to innovation, sustainability, and public service continues to shape the future of Andhra Pradesh. Thank you for gracing this summit, sir. We now request Professor D. Narayan Rao, Executive Director, Research, SRM Group of Institutions, to kindly lead the dignitaries onto the dais. We now begin this landmark event with the tradition that symbolizes the awakening of knowledge, the lighting of ceremonial lamp. May I request our esteemed dignitaries to kindly join us for the lamp lighting ceremony. Let us begin with the welcome address by Dr. P. Satyanarayanan, Pro-Chancellor, SRM University, Andhra Pradesh. We request you to kindly deliver the welcome note, sir.
A very good afternoon to you all. Esteemed guests, scientists, policymakers, innovators, and friends. At the very outset, I extend our deep gratitude to the Honorable Chief Minister of Andhra Pradesh for his presence and his unwavering support for clean energy innovation. Sir, your leadership in advancing renewable energy, hydrogen infrastructure, and world-class research ecosystem continues to inspire not us, the students and faculty, but the entire scientific and industrial community. I warmly welcome Dr. V.K. Saraswat, Honorable Member of Niti Aayog, Dr. Pemesini Chandrasekhar, Honorable Minister of State for Rural Development and Communications, Shri K. Vijay Anand, Chief Secretary, Government of Andhra Pradesh, Dr. Ashish Leela, Director CSIR, National Chemical Laboratory, Dr. Sujit Pillai of National Hydrogen Mission MNRE, Dr. R.K. Malhotra, the President of Hydrogen Association of India, Mr. Pranav Tanti, the President and CEO of Synergen Green Energy Inc. USA, Mr. Anil Kumar, MD and CEO of Greenco, and all other distinguished delegates and the participants. It is a true pleasure to welcome you all here to this Green Hydrogen Summit, a platform that reflects our shared commitment to a cleaner, more sustainable, and forward-looking energy future. This is just not about saving the earth. It is about saving ourselves. The earth will continue to exist regardless of climate, temperature, and terrain. But we, the ecosystem that support the human life, need balance to survive. What's truly at stake is not the planet, but the environment stability we depend upon, air we can breathe, water we can drink, and the temperature we can live with. Our ongoing dependence on non-renewable energy, fossil fuels that pollute the air, warm the planet, and degrade the ecosystem is pushing towards a future that is just not uncertain, but hazardous to human existence. That is why the transition to renewable energy is not just important, it is urgent. And in this transition, the green hydrogen has a very critical role. It is one of the few clean energy sources capable of addressing industry scale needs, long distance transport, grid level storage, and the areas where the batteries and the technologies fall short. Recognizing this, The Honorable Chief Minister has taken a pioneering step by launching Andhra Pradesh Green Hydrogen and Green Ammonia policy in 2023. This policy outlines a clear vision to produce 500,000 tons of green hydrogen per year and 2 million tons of ammonia per year, backed by strong incentives. From ST reimbursements, electricity duty waivers, to land concessions and priority port access. These are not symbolic steps, they are concrete foundations to make Andhra Pradesh a national and a global hub for green hydrogen. And what makes this even more inspiring is the mindset behind it. It was on this very stage that Chief Minister once said, being a visionary is a problem. And yet, he chose to envision what others wouldn't, that courage to move ahead despite the weight of uncertainty is what defines his leadership and that makes history. At SRM, we believe in that vision and we are committed to growing with the Andhra Pradesh state. As the Andhra Pradesh builds Amravati as a capital of the future, we at SRM University AP want to grow alongside it to be part of its transformation and history. In line with this vision, we are proud to announce the launch of the SRM Institute of Emerging Technology. At its heart, it will have the Department of Energy Engineering, one of its kind, committed to research, innovation, and skill development in the clean energy space. Apart from this, we are also planning for health engineering, financial engineering, defense engineering, and sports sciences. So that makes this SRM Institute of Emerging Technology to be different from the other institutions in India. If we are able to, if we are to be the last generation to depend upon fossil fuels, then the next generation must be the first to lead the clean energy revolution. While the government set policies, industries build systems, it is the youth with their ideas, innovation, and courage who will carry this transformation forward. They must not just inherit the planet, they must be empowered to reimagine it. Let us not fail them. Let us ensure that this borrowed planet passed on to us by our ancestors is returned to the next generation in a livable, breathable, and a beautiful form. Let us be the last generation that depended on fossil fuels and at the first that made the clean energy truly universal. Let's work for it. Thank you very much.
Thank you, sir, for your warm and inspiring words and for always motivating us to dream big. We now invite Professor D. Narayan Rao, Executive Director, Research, SRM Group of Institutions, to set the stage by introducing the vision and purpose of Green Hydrogen Summit.
Honorable Chief Minister of Andhra Pradesh, Sri Nara Chandrababu Naidu Garu, well-wisher and mentor of SRM AP and Honorable Member of Niti Aayog, Dr. Saraswat, very sharp and young Minister of State for Rural Development and Communications, Dr. Pemasani Chandrasekhar, President of SRM Group, Dr. Satyanarayanan, the Chief Secretary, Sri Vijayanand, the well-known industrialist, Mr. Pranav Tanti, Professor Malhotra, President of Hydrogen Association of India, Dr. Ashish Lele, Director, CSR, National Chemical Laboratory, Pune, Dr. Sujit Pillai of the National Hydrogen Mission of MNRE, my colleague, Professor Satish Kumar. I extend a warm welcome to all of you, particularly the industrialists who came from different parts of the country and abroad, the delegates of the Hydrogen Summit, scientists, faculty members, research scholars, and my dear friends of print and electronic media. Once again, I have a great pleasure in inviting all of you to the Green Hydrogen Summit 2025 being held at SRM AP today and tomorrow. India's deep commitment to aspirational climate goals, which the Honorable Chief Minister also mentioned in the last few minutes in the discussion meeting, these commitments have been widely acknowledged by the Committee of Nations. India plans to become energy independent by the year 2047. The Union Cabinet approved several science and technology missions, including the prestigious National Hydrogen Mission with an impressive outlay of 19,744 crores of rupees. The key objectives of the mission are making India a leading producer and supplier of green hydrogen to the world, reduction in imported fossil fuels. Expected outcomes of the mission by 2030 are development of green hydrogen capacity of 5 million metric tons per annum, indigenous development and manufacturing of electrolyzers, creating opportunities for employment and economic development. Hydrogen, with its remarkable attributes of high energy density, zero emissions, has a wide variety of applications. With the permission of the Honorable Chief, I want to mention some of the potential applications in this country. Ministry of Road and Transport and Highways will enable adoption of green hydrogen in the transport sector. Ministry of Ports, Shipping and Waterways will play a crucial role for establishing capabilities for export of green hydrogen and its derivatives. Now, hydrogen-powered drones are becoming very popular all over the world. The Honorable Chief Minister has created Drones Corporation of Andhra Pradesh, which could consider to develop hydrogen-powered drones. This will be the first state in the country to develop hydrogen-powered drones. Ministry of Petroleum and Natural Gas will be facilitating uptake of green hydrogen in refineries and city gas distribution. Green steel. Steel production is one of the potential sectors where green hydrogen can replace fossil fuels. Ministry of Steel will drive adoption of green hydrogen in the steel sector. European countries say we'll import only green steel. So this is a great opportunity for Visakhapatnam steel plant to go for steel production using hydrogen. Now I have a request to the young Minister of State for Telecommunications. The backup power requirement of telecom towers presents an apt opportunity to deploy reliable and on-demand renewable energy solutions. Where it is estimated that these towers in the country consume about 2 billion liters of diesel every year. So hydrogen could be considered as a backup energy source. Ministry of Railways is working on transitioning towards adoption of green hydrogen in view of its ambitious plan to reduce the carbon footprint. Ministry of Railways has already developed a hydrogen-powered fuel cell-based train with 10 coaches, and the pilot hydrogen-powered train will be demonstrated in September 2025, that is the next 2 months, between the stations Jhind and Sonepat in Haryana. In March 2025, the Honorable Chief Minister directed SRM University AP to develop a hydrogen-powered train between Hyderabad and Vijayawada. Then immediately Chief Minister said, no, Narayan Rao, between Hyderabad and Visakhapatnam. Yes, sir, we are at it. Now, yeah, please. SRM University has an MOU with the Integral Coach Factory of the Ministry of Railways to develop the hydrogen powered train. Sir, we are at it, working under your direction. We earnestly request the kind support of the Honorable Chief Minister and the Ministry of Railways for the development of this hydrogen powered train as a flagship project of the state of Andhra Pradesh. Sri Chandrababu Naidu, as an intellectual, is attracted by the aesthetic beauty of science and technology. And as a people's leader, he is greatly attracted towards technology and the promise it holds to transform the state of Andhra Pradesh and its economic development. Let's give a big applause to the aligning with the ambitious plans of National Hydrogen Mission and with a foresight that the first entrance into the business of hydrogen can reap more benefits than others, our visionary Chief Minister has made Pudimadaka near Visakhapatnam as the first and the largest hub of green hydrogen in the country. The Visakhapatnam Hydrogen Hub will be producing about 1.5 million metric tons of green hydrogen per annum, 3 million metric tons of green ammonia, methanol, etc. Green hydrogen produced at Visakhapatnam could be used by Visakhapatnam Steel Plant, HPCL, NTPC, fertilizer industries, and many others. Sir, I am glad to inform the Honorable Chief Minister and the audience present here that the faculty members of SRM University AP have indigenously developed an electrolyzer which the Honorable Chief Minister just now visited. This can produce 500 kilograms of green hydrogen per annum, and it is being demonstrated during summit. It is scalable to produce 150 tons of green hydrogen per annum. We request the Honorable Chief Minister to consider industry, university, government collaborative venture. We propose to establish an innovation center at SRM University AP to develop indigenous technology to produce, store, and utilize hydrogen as a green fuel. The goal of the proposed center in the next 2 years would be to develop and demonstrate a hydrogen-powered car between Vijayawada and Visakhapatnam, and with refueling facilities along the way. At present, hydrogen costs about 350 rupees per kilogram, which can fuel a car for a distance of 20 to 25 kilometers. The proposed innovation center could bring down the cost to 200 rupees per kilogram of hydrogen by developing more efficient catalysts for electrolysis and reducing the power consumption for producing hydrogen. Sir, you are kindly aware that on 30th June 2025, the government of Andhra Pradesh approved Amaravati Quantum Valley Declaration. IBM will be installing and maintaining a 156 qubit quantum computer at Amaravati Valley on 1st January 2026. Sir, this will be the first and most powerful quantum computer not only in the country and in South Asia. Friends, establishment of Amaravati Quantum Valley is also a catalyst for our green hydrogen mission. The quantum technologies help us design advanced catalysts, develop safer hydrogen storage systems, and create ultra-sensitive sensors for monitoring the safety. With the quantum simulations, we can reduce the cost of hydrogen and to increase the efficiency of green hydrogen production. Looking into the future needs courage and insight, and fortunately, our visionary Chief Minister has both. Let's give a big applause. During the exciting decade of 2014-24, the Government of India launched several SNT missions, including the National Hydrogen Mission, National Quantum Mission, National Semiconductor Mission, National Mission on AI. The state of Andhra Pradesh has taken up these missions at an unprecedented fast pace. Dear friends, with all these technological advances and the vision and dynamic leadership of our beloved Chief Minister, the state of Andhra Pradesh will be very different from what it is by 2047, Swarnandhra 2047. Jai Hind, Jai Bharat, Jai Vigyan. Thank you. Now I request all of you to give a standing ovation to this dynamic, visionary Chief Minister.
Thank you, sir, for framing the summit's goals with such clarity and depth. Now, it's our honor to invite Sri K. Vijayanand IAS, Chief Secretary, Government of Andhra Pradesh, to address the gathering.
Honorable Chief Minister of Andhra Pradesh, Sri Nara Chandrababu Naidu Garu, Honorable Member of Niti Ayog, Dr. V.K. Saraswat Garu, Honorable Minister of State for Rural Development Communications, Dr. Chandrasekhar Pemasani Garu, Pro-Chancellor SRM University AP, Dr. P. Satyanarayan Garu, distinguished guests, esteemed faculty, students and industry leaders and media. A very good morning and warm greetings to all of you. It is a privilege for me to be part of this transformative gathering, the Green Hydrogen Summit 2025, which is hosted by SRM University and New and Renewable Energy Development Corporation, Government of Andhra Pradesh. This summit is a testament to our collective commitment to building a sustainable future powered by clean energy. Today, we have gathered here to discuss one of the most transformative energy solutions of our time, that is green hydrogen. This summit is not just a platform for dialogue, it is a call to action for governments, industry, and academia to collaborate in building a sustainable and resilient energy ecosystem. I extend my heartfelt gratitude to SRM University for graciously hosting this summit and providing a platform for collaboration, innovation, and progress in clean energy sector. As the world confronts the urgent challenges of climate change, the transition to green energy offers a compelling and scalable solution to all of us. This pathway not only decarbonizes our energy systems, but also redefines industrial processes, transportation, and agriculture. Green energy derived from solar, wind, hydropower, geothermal, and biomass is the foundation for this transition. It is a clean, renewable, and resilient energy system. By harnessing this energy to produce green hydrogen through electrolysis, we unlock a versatile fuel that emits only water when it is used. Green hydrogen is rightly called the Swiss knife of decarbonization because, due to its wide-ranging applications from refining to steel making to aviation and shipping. The green hydrogen ammonia value chain is critical for decarbonization in particular. It enables deep emission cuts in hard-to-abate sections like steel, cement, and heavy transport. Energy storage and transportation also value chain is used to allow efficient storage and long-distance transportation of renewable energy, balancing supply and demand. In case of industrial applications, this provides high-temperature heat for industrial processes without carbon emission. In case of climate mitigation, by reducing CO2 emissions, it contributes to limiting global warming to 1.5 degrees centigrade, as outlined in international climate agreement. As a economic growth perspective, it opens new avenues for job creation, innovation, and green industrial development. Looking and taking all these factors into consideration, Government of India has made significant strides in promoting green hydrogen as a cornerstone of its clean energy transition. National Green Hydrogen Mission is launched in January 2023. Is the India's flagship initiative to promote green hydrogen. It aims to produce 5 million tons of green hydrogen annually by 2030, attract investment worth 8 lakh crores, create more than 6 lakh green energy jobs. The Strategic Interventions for Green Hydrogen Transition is a program supported with NGHM. It provides for 17,490 crores allocated from 2023 to 2029 as production-linked incentive PLI scheme for electrolyzer manufacturing and hydrogen production. India aims to reduce the cost of green hydrogen from $4.5 in 2023 to $1 by 2030 by leveraging low-cost renewable energy, domestic electrolyzer manufacturing. And India is also focusing on the infrastructure and export strategy and building a scalable hydrogen ecosystem for industry and transport. Strategic partnerships through India, Middle East, Europe Economic Corridor to boost hydrogen exports. Government of Andhra Pradesh, under the visionary leadership of our Honorable Chief Minister, Sri Nara Chandrababu Naidu Garu, we are playing a strategic role in this entire program. Andhra Pradesh is proud to be at the forefront of this India's clean energy revolution. With abundant RE resources, a proactive government, and a thriving industrial base, we are ready to become Green India, green hydrogen powerhouse. Under Swarnandhra Vision 2047, we are committed to become a hub for clean energy innovation and green hydrogen exports. The state has launched Andhra Pradesh Integrated Clean Energy Policy 2024, which provides a comprehensive framework for green hydrogen production and infrastructure, electrolyzer manufacturing, hydrogen-powered mobility and logistics, export-oriented hydrogen corridors. The state targets around 10 lakh crores of investment in clean energy, and the state is offering capital subsidies, GST relief, stamp duty concessions, and incentives for battery storage systems to attract green hydrogen and renewable energy investment. Recently, India's first integrated green hydrogen hub by NTPC Green Energy, where Government of Andhra Pradesh New and Renewable Energy Development Corporation is also involved. The Honorable Prime Minister has laid foundation stone for 1,200 tons per day green hydrogen at Pudimadaka in January 2025. You are also aware 1 MMTPA green hydrogen based green ammonia manufacturing facility at Kakinada by AM Green Ammonia Private Limited they have already started. They did the groundbreaking, already started the work with an investment of 12,000 crores and creating 2,600 jobs. Development of a 2 gigawatt electrolyzer manufacturing facility at Kakinada by Chan Cockerill Greenco Hydrogen Solutions Private Limited is also, they have laid the foundation stone, and they have started the activity with an investment of 2,000 crores and creating 5,000 jobs. We are also happy to announce that India's first pilot project blending green hydrogen with LPG for industrial heating with an annual green hydrogen capacity of 25 tons per annum at Rockman's Tirupati facility by Hero Future Energies and Rockman Industries. The total investment is approximately 1,000 crores with 2,000 existing employees at the factory. What is the road ahead for us? While these challenges remain, such as high capital costs, energy losses, and storage complexities, our path forward is very clear. There is a need for policy support and subsidies for early stage investments, which by our policy, we have provided the best of the industry kind of incentives in this sector. International supply chain development is also one thing important, and continued R&D for efficiency and cost reduction, academic and industry participation to drive innovation. The success of this green hydrogen depends on collaboration between government, academia, industry, and civil society. This summit is a shining example of such collaboration. It brings together thought leaders, innovators, and policy makers to chart a roadmap for a cleaner and more resilient future. I urge all the stakeholders who are present here to continue this dialogue beyond today. Let us build a pilot projects, share knowledge, and create scalable models that can be replicated across the country. As we look ahead, let us remember that the transition to green hydrogen is not just about technology, it is about vision, it is about courage, and it is about commitment. And Andhra Pradesh stands ready to lead, and we invite all of you to join us in this journey. Together, let us make Andhra Pradesh a model for sustainable energy and a proud contributor to India's green future. Thank you.
Thank you, sir, for your insightful address. It's our honor to invite Sri Pranav Tanti, President and CEO, Synergen Green Energy, to address the gathering.
Honorable Chief Minister, Chief Secretary, respected dignitaries, esteemed delegates, distinguished guests, I'm truly honored and humbled to stand here to welcome you. It is for sure a great privilege to welcome you all to the great state of Andhra, where the Green Hydrogen Summit has been established. Andhra Pradesh is delighted to host this remarkable gathering of visionaries, industry leaders, policymakers, future generations, and experts who share a common goal: to harness the potential of green hydrogen as a pivotal force in the transition towards a sustainable and clean energy future. If I can pause and ask a basic question, why hydrogen? What makes hydrogen so special? Hydrogen is the simplest element. It is the most abundant element. So why hydrogen? Well, the answers are in the challenges that we all face in this energy transition. In the renewable space, in the green space, we all face the issues of expansion beyond a certain capacity. All of us have been working with electrons for many decades, and we know that electrons are very notorious. They don't like to be told what to do. They don't like to be stored. They don't like to be moved around. And I can go endless. We've seen many challenges of the grid, challenges of the green power. I think hydrogen and hydrogen's derivatives is a simple solution. We need to figure out how do you make a transition towards a molecule. A green electron to a green molecule gives those answers. Hydrogen is pivotal in transforming the electrons to molecules to unlock the potential to store, to transport, to consume the green electrons when you need it. Basically pivotal in displacing the fossil fuels. Andhra Pradesh, with its strategic initiatives and commitment to clean energy, is proud to lead the way in fostering discussions and collaborations that will drive innovations in the green hydrogen. This all comes with a great vision that the policymakers, the chief ministers, the dignitaries have. This summit serves as a vital platform for exchanging ideas, showcasing advancements, and exploring opportunities for collaborations across sectors. Our company name, Synergen, is coined using two terms: synergy and hydrogen. It's simple as it stands. We strongly believe that the key to unlocking the next phase of expansion is undoubtedly collaboration. We all need to come together as one force to make it a success. We are in the advanced stages of development of green hydrogen and green ammonia manufacturing facility with a capacity to manufacture 40,000 tons of green hydrogen in the state of Texas in US. With this anticipation, we believe that the commissioning is possible in 2028, and a combined capex of renewable energy and a green fuel of $2 billion. This was only possible because of the efforts we put in fostering partnerships and collaborations over the last 4 years. Throughout this summit, let us engage in meaningful dialogue, challenge conventional thinking, and inspire one another to take bold steps towards achieving the common objective. Your insights, experiences, and commitments will lay the groundwork for transformative change. Once again, welcome to the Green Hydrogen Summit at Andhra Pradesh. Let us harness the power of collaboration and innovation to fuel the sustainable future for the generations to come. Thank you.
Thank you, sir, for your inspiring message. It's our immense privilege to invite a distinguished architect of India's science and technology policy, Dr. V.K. Saraswat, Honorable Member, Niti Aayog, Government of India. A driving force behind India's strategic advancements, Dr. Saraswat's insights continue to shape the nation's innovation landscape. We request you to deliver the keynote address, sir.
Namaskara. Very good afternoon, Honorable Chief Minister of Andhra Pradesh, Shri Chandrababu Naidu Garu, Honorable Minister of State, Dr. Chandrasekhar, Shri Satyanarayan, and many of my colleagues, distinguished scientists, industrialists who are on the dais, off the dais, ladies and gentlemen, members of the media, it's indeed a pleasure to be part of this Green Hydrogen Summit. We were just discussing, this is a journey which I started about 7 years back or 8 years back, when I made a presentation to our Honorable Prime Minister and said India should launch a hydrogen mission. I think it was around 2017 or so, 17 or 18. And he immediately picked up that, and the story is known to you today, with so many of you have talked about the hydrogen mission of that. So the vision of our Prime Minister is to decarbonize our energy system. That's why he has committed in the NDC that we will be 500 gigawatts of renewable power or non-fossil power by 2030. He has also committed that we will have energy intensity reduced by 45%. And we will have more than 2.3 billion of carbon absorption, so that we can have, through afforestation, that much of CO2 that can come. And ultimately net zero by 2070. Now, what is the role in this? Because energy is such a sector which is so open. We have been depending upon fossil fuels for energy for the last so many decades and almost a century. And now we have worked out, under the leadership of our Honorable Prime Minister, the energy mix for our country. The energy mix for the country today is that we will work on mostly on the renewable energy. That's why we said 50% by 2030. We will work on alternate fuels, non-fossil fuels, alternate fuels which are less polluting, like ethanol, methanol, ammonia. We will give a major push to nuclear energy. That is another area which you might have heard in the recent past. It has been announced in the last budget that India will have 100 gigawatts of nuclear power by 2047. Why do we need nuclear power? Because when you talk of renewables, it has its own vagaries with respect to variations in the availability. And for meeting that base load requirement, the most non-polluting form of energy is nuclear. So that's why the nuclear comes, and now new technologies in nuclear are also emerging, which will be able to meet the requirement of power for difficult to abate sectors like steel, cement, refineries, and so on. In this kind of an energy mix, when we talk of, mobility becomes one of the major requirements because that's another polluting area. And in that mobility, when you talked of alternate fuels, the top cleanest fuel comes is hydrogen. Hydrogen is the cleanest fuel available, and that's why it's called fuel for the future. Unfortunately, or fortunately, we have been using hydrogen in various fields, refineries, petrochemicals, many other areas. And we have been producing hydrogen mostly from the natural gas, sometimes from coal, and sometimes from biomass. After doing a lot of analysis, what are the various means of producing hydrogen, people have started giving it color. Somebody says gray hydrogen, somebody says blue hydrogen, somebody says pink hydrogen, turquoise hydrogen, white hydrogen. Now this kind of a color is mainly based upon what is the total carbon dioxide emission that takes place in the process of production of that hydrogen. That is what it's called, that color is given. But as you want to do the green hydrogen, it has got its own problems with respect to the cost. We know that hydrogen can be produced in the most non-polluting manner through the electrolysis of water using, again, non-fossil energy, that is renewable energy, which is a non-fossil energy. If we can do that, we can get it. But while the cost of renewable energy has come down, but the cost of electrolyzers, which are responsible for electrolysis of water, is even today very high, which results into a differential of almost $4 to $5 with respect to the cost of gray hydrogen or blue hydrogen for that of the green hydrogen. Now, one of the major things which our Honorable Prime Minister mentioned when the National Hydrogen Mission was announced, that as a target, most of the industries should switch over to the use of green hydrogen so that progressively over a period of time we can 100% switch over to green hydrogen. Knowing very well that to start with green hydrogen is not affordable. But when from Niti Aayog, we started interacting with various industries, whether it was the steel industry or the cement industry or refineries, everybody came to only one point, sir, there is no way we can change over. Two reasons. One is the affordability, because unless the cost of green hydrogen comes to less than $2, the steel industry will say, my cost of production of steel will go up by about 20 to 30%, so I'll remain non-competitive. And same is the story with other sectors also. So what is the answer for that? But we have to ultimately reach the green hydrogen because that is the most non-polluting. In that case, there are intermediate steps that we can take. So that is why in the morning, Dr. Malhotra and Ram Kumarji and Dr. Lele, everybody talked that we should work on blue hydrogen so that we can penetrate into the industry at the earliest. That would be our motive. And hence, I would put it this way, that we have today, knowing this problem, that, and the world also has recognized this problem of affordability of green hydrogen. So in the G20 discussions, when the G20 was held in India, there was a major dialogue among the various nations. And all nations, after a lot of discussion, said that I think the mission name should be changed from green hydrogen to clean hydrogen. And if those of you who had a chance to see the declaration, final declaration, I think that word has been changed to clean hydrogen.
And if you now look at the speeches made by most of the Americans and the Japanese and the Germans, everybody is nowadays talking of clean hydrogen. Everybody has realized that the pathway to reach the green hydrogen is through the other processes which are non-polluting. Now, other process which are non-polluting is a blue hydrogen. And we can use the existing fossil fuel resources like natural gas and coal and do carbon capture and utilization and produce blue hydrogen. And the cost of that will be in the region of $2 to $2.5 to $3. That is a kind of a number. And the carbon footprint will be well within the definition which has been given by the MNRE today, that the green hydrogen is green if the carbon footprint is 2 kilograms of CO2 per kilogram of. So it will be very much in that. So we will be meeting both the objectives. Now, opportunities are there because ultimately by 2047 or 2040, we have to make green hydrogen affordable. Our Honorable Chief Minister just now was telling that we have to work today, and Andhra Pradesh has the greatest opportunity to do that. Because I know the leadership of Honorable Chief Minister is so great, because I have seen him transforming the IT infrastructure in the state of Telangana, that is Hyderabad, and bringing it as a city which is comparable to Silicon Valley. It became the Silicon Valley of India. That was because of the leadership and the vision of our Honorable Chief Minister. I'm quite certain that India's green hydrogen mission, which is green hydrogen, some numbers were already talked, so I'm not going to repeat. In Andhra Pradesh will be the valley of green hydrogen. All the projects which were narrated by them, I think they are the beginning for that. And I would put it this way, that we have to tread towards reducing the cost of hydrogen production, transportation, storage, and ultimately dispensation to whichever utility it is needed. And for that, technologies which are required, I think Andhra Pradesh, with the help of SRM and other institutions, can certainly meet them. A few of them I would like to mention, which I mentioned to the Honorable Chief Minister during the industry interaction, that we should set up a very large size electrolyzer plant in Andhra Pradesh. I'm very happy Dr. Ram Kumar was telling that we are setting up something in the Kakinada region, if I'm not wrong, setting up a plant of something like 2 gigawatt and things like that. But friends, as I gave the number in the morning, unless we have electrolyzer plant capacities to the hour, something like terawatt hours, and the cost of electrolyzer comes down from today's $600 to $800 per kilowatt to something like $130 per kilowatt, and the power cost is $20 per megawatt, then you will be able to get hydrogen at $2. This is the equation we have to meet. And for that, this is the right place. This is the place because already industrialists have taken initiative, so you should set up an electrolyzer plant. For storage, country is now working towards storage methods. And the only storage method that has been found most suitable today is the gaseous high pressure storage. And gaseous high pressure storage using the Type 4 cylinders. Type 4 cylinders are being produced today in a small, like IIT Bombay is making one Type 4 cylinder. Some small institutions are making. Some industries are also coming up. But I think this should become one of the country's largest hub for manufacturing Type 4. We should set up an ecosystem in Amravati for manufacturing Type 4 cylinders along with the carbon fiber and also the facility for testing. We should not be sending our Type 4 cylinders for testing to Germany and other places. We should do it all by ourselves. So that is the one which I would like to be done today. And third one is, ultimately we have to go for mobility with the hydrogen. And the only way we can do is through the fuel cells. You must have heard the lecture by Dr. Lele in the morning. And he has developed the technologies for fuel cells. Others are also available. Others have also done the same thing. I think in this valley, what we are talking for Andhra Pradesh, there should be a large-scale fuel cell manufacturing facility with the help of industry and academia indigenously done by us. Sir, I am a guy who believes in Atmanirbhar. Throughout my life as a defense scientist, I worked for self-reliance. Now we are talking of self-reliance in energy sector. There's no point in continuing to get all the solar cells imported from China and saying that I got 500 gigawatts of solar. I want those solar cells to be manufactured here. That's why government has given PLI scheme. Electrolyzers, PLI scheme. Fuel cell, PLI scheme. Now the time has come for us to take all of that into a large-scale production, make use of them, and make it more and more indigenous. And that is where Andhra Pradesh Hydrogen Valley will become the hub, and the leadership of our Honorable Chief Minister will be the big word, big guidance for all of us. The kind of work which was done for IT industry in Hyderabad, the same should be done under his leadership in Andhra Pradesh. I urge to all of you to participate in that. Thank you very much. Namaskar.
Thank you, sir, for your inspiring words and for highlighting the critical role of green energy in shaping the future of India's mobility and infrastructure. Now, I request Dr. Chandrasekhar Pemasani, Honorable Minister of State for Rural Development and Communications, Government of India, to address the gathering.
Thank you. Honorable Chief Minister of Andhra Pradesh, Sri Nara Chandrababu Naidu Garu, a leader who not only transformed Andhra Pradesh, but also inspired an entire generation of policymakers, including myself, across the country. And Dr. V.K. Saraswatji, Honorable Member Niti Ayog, whom I have just seen how deeply passionate about this renewable energy, and Sri K. Vijayanandanji, Chief Secretary, Government of Andhra Pradesh, who has longest experience in electricity and energy, and all the founders of this university, distinguished guests, including elite industrialists, entrepreneurs, researchers, innovators, media, and everyone. Thank you. Welcome to the gathering. As we gather here in Amaravati, the future visionary capital of Andhra Pradesh, we stand at the threshold of a transformative era in energy. We are at a decisive crossroads where the climate change is accelerating, global fossil fuel reserves are dwindling, and the demand for clean, sustainable energy is rising faster than ever. According to the estimates, by 2040, India will be the largest consumer of energy. Today, we import 40% of primary energy with a spend of 8 lakh crores, that's close to $90 billion annually. Therefore, the energy security is India's national security. In this process, green hydrogen is not a distant hope. It is the imperative that will architect the future of our nation, our planet, and the generations to come. As everyone has said, green hydrogen is produced through electrolysis, using water and renewable energy, emitting nothing but oxygen and a clean hydrogen. Though the concept of green hydrogen is not new, it is only in the past decade that technological advancements and declining costs of renewable energy, including solar and wind, have made it commercially viable. It holds the unique power to decarbonize the sectors that have stubbornly resistant to change, including steel, cement manufacturing, refineries, chemical, heavy transport, and so forth. Therefore, this is not just about energy, it is about reimagining industrial processes that have defined our economy over a century. And India is uniquely positioned to alter this course. Recognizing this, our visionary Prime Minister, Sri Narendra Modi ji, has come up with this renewable energy policy. India has 300 sunny days every year and a vast coastline ripe for both wind projects and solar power. India has an ambitious target of 5 metric million tons of green hydrogen by 2030. Therefore, the government of India has given a budgetary allocation of close to 20,000 crores. And the goal of these 20,000 crores is to reduce a current 8 lakh crore annual to every year 1 lakh crore reduction. So by 2030, we can largely get to independence in energy. Recognizing this national mission, and our Honorable Chief Minister, who is another visionary leader, wanted to take Andhra Pradesh to be the heartbeat of this hydrogen hub. If you look at his past history, when India was going through national energy crisis in 1999, he introduced bold power reforms despite political repercussions. No other chief minister has dared to do these kind of reforms other than Sri Nara Chandrababu Naidu garu. And these reforms laid the foundation for the state's energy advancements today, reducing cost through solar and wind integration. His vision transformed Telangana into a global height and innovation hub today. He is replicating the same today with the Amaravati as a technology-driven capital by coming up with innovative ideas, Quantum Valley and probably Hydrogen Valley soon, along with sports cities, defense clusters, things that are rarely be seen by many other leaders other than him. And Andhra Pradesh has set this hydrogen hub, our targets out of 5 million metric tons of India's target, he wanted to produce 20% of that, that is 1 million metric tons in Andhra Pradesh alone by 2030. And this is not just a vision. We execute this by relentlessly working hard. If you look at it, NTPC Green Energy is investing 1.85 lakh crore. This is the India's largest green hydrogen hub, producing 1,500 tons per day of green hydrogen and another 7,500 tons of its derivatives, whether it is green ammonia, methanol, etc. And the second project, Hero Future Energies, this is the India's first green hydrogen plant, blending both hydrogen and LPG so that it's commercially viable. So these investments, along with our extensive ports, coastline, indicates, signals to the world that clean energy can be scalable and profitable. Though, as our previous members have said, there are challenges. Cost is an issue. Globally, green hydrogen costs around $3 to $6 per kg, compared to gray hydrogen $1 to $2. Scaling up electrolyzer efficiency has been a challenge. India water scarcity is an issue. To produce 1 kilogram of green hydrogen, you need 9 liters of fresh water, and India's water requirements are doubling. Therefore, this is when the innovation is really important. Our Honorable Chief Minister has given huge lands for these universities, 100 acres, 200 acres, not just to set up world-class universities, to really innovate and problem solve, not just for Andhra Pradesh, but India and to the world. I mean, these are beautiful universities that were built with large investment, and we appreciate and thank the university. But at the same time, all these challenges, you look at the America, the Harvard, Stanford, Yale, these are the universities that solve large human problems. And we want the SRM, WIT, and all the universities that are establishing here want to be the same way or probably better than them in the generations to come. And we have to solve these. What are the solutions, right? If you have the water scarcity, how can we do electrolyzers using salt water? How can we create lightweight storage? How can we create breakthrough in fuel cell chemistries? So these are all the things that both the industry, universities, and our government is always willing to do policy changes, whether it's tax breaks, subsidies, and the draft integrated plan of 2024. All of these must come together. With these right investments and government policies, we can create jobs and provide power to the rest of the world. And this is our moment to lead, to leap, and to leave a legacy. And I once again thank you for everyone being here and inviting me for this important conference. Thank you.
Thank you, sir, for your inspiring words and support. Ladies and gentlemen, the journey towards a green, self-reliant India needs more than innovation. It needs a visionary leadership to steer us to dream beyond. Today, we are honored to have with us our visionary leader who has transformed Andhra Pradesh into a hub of progress with remarkable strides in education, technology, infrastructure, and sustainable growth. His vision continues to inspire countless individuals and shape the future of our state. It is with great pride and deep respect that we now invite the statesman of our modern Andhra Pradesh, Honorable Chief Minister Sri Nara Chandrababu Naidu Garu, to share his vision and address this distinguished gathering.
Honorable Minister of State for Rural Development and Communications, Government of India, Dr. Chandrasekhar Pemmasani, Honorable Member, Niti Ayog, Dr. V.K. Saraswat, Pro-Chancellor, SRM University, Sri P. Satyanarayana Garu, Chief Secretary, Government of Andhra Pradesh, Sri Vijayanand Garu, Pro Vice Chancellor SRM University, Professor Satish Kumar, Director CSIR, NCL Pune, Ashish Lile Garu, President CEO, Synergen Green Energy, Sri Pranav Tanti Garu, Executive Director Research SRM, respected Sri Narayana Rao Garu, Convener NHM Sujit Pillai Garu, and industrialists and friends and media. I am very happy to be here second time after I assumed charge. Today, one of the most important subjects SRM is conducting, really I appreciate them. This is Green Hydrogen Summit 2025. Why I am saying this is very, very important. I have seen transformation in energy sector and also fuel sector. If you can go back 40, 50 years back, at that time, no energy. India, when I born, elementary school, when I used to go to school, we used to use only lanterns. Youngsters may forget about it because you didn't witness that type of situation. After that, power has come, electricity has come to villages. That is a big news and also very, very surprise. Then if you see after some time when I became MLA, there was a big problem of energy, low voltage, all pump sets will be totally spoiled. Even sometimes all crops will be withered away. There were days when I was Chief Minister of Andhra Pradesh, 50% of time whenever there is a session, we are having a budget session in March. March is the best season for agriculture. They need power and also hot. Automatically there is no power. All MLAs used to block the assembly through adjournment motions. Then I used to discuss about, there were days we adjourn the assembly, go to the field, what is happening, and then come back and report to the assembly members. Then I thought in this country, better to go for reforms. Already one state has introduced reforms, Orissa. They were forced to withdraw reforms again because of pressure from public and political parties. In this country, I started first time power sector reforms in 1999 or 2000. That is the beginning. First regulatory commission has been set up. And also transmission, distribution, generation companies have come for more accountable and transparency and better delivery. We are able to manage power position very well at that time. If you see, sometimes we have to pay some price also. I brought power sector reforms. I lost power in 2004. Even all my MLAs, everybody told me, no, you are moving very fast because sometimes some reforms, some people will get adverse effects in the short term, but ultimately it will be beneficial. Again, if you see clean energy, solar, wind, all these things, around 2014, prohibitive cost, 14 rupees unit production cost. Nobody thought about it. At that time, Government of India has come forward, Honorable Prime Minister Narendra Modi ji, to promote green energy in a big way, solar, wind, and everything. As rightly mentioned Mr. Saraswat, panels we had to import from China with a prohibitive cost also. So many challenges, opportunities. Then we have scaled up in a big way, solar energy. Now it has come 2 rupees 20 paisa evening, that too whenever there is a wind. Now pumped energy, that is one more concept I started not now, around 95, 97 in Sri Salem. I started reversible pumps for peak load factor, how to manage. Then that has gone at that time, sometimes power demand also is changing according to situation. Earlier I had a problem, power shortage in the evening and also morning, 10 to 11 like that, because agriculture operations. Today, power is generated during the day. I don't have any problem in the morning. I need more power in the evening sometimes, peak load out of balance. Now pumped storage energy has come. Battery has come. Battery is very costly. But ultimately, sustainability is the problem and cost is the problem. Now we are all talking now. Clean hydrogen. That is where how to make it power cost effective and affordable. Either that is a very interesting experiment we are all thinking now. If you see global warming, all countries are moving how to go for green energy. If you see here, Honorable Prime Minister has announced 500 gigawatts non-fossil fuel energy by 2030. And also net zero by 2070. Clean hydrogen and its derivatives. We are aiming decarbonization. And we are discussing today and tomorrow here. This is where circular economy, recycling of water, recycling of energy recovery, so many things we are going to discuss. In this, Andhra Pradesh wanted to play very major role. There is one advantage I wanted to inform all of you. Andhra Pradesh, one advantage solar, second advantage wind, third advantage pumped energy, fourth advantage we are having beautiful sea coast, nearly 1,000 kilometers. Now green hydrogen, you wanted to, green hydrogen or ammonia, all these things you want to export, you need port facility. We are having 1,000 kilometers. Now people are coming to Andhra Pradesh because this is another advantage for us. Now in Visakhapatnam, our NetCap and Government of India NTPC subsidiary, they are going green hydrogen. Even Greenco is coming in a big way. Already they are having one hybrid model, what I told you very clearly, solar, wind and also pumped energy, very cost effective. Now they are going in a big way, green ammonia in Kakinada. Even one more friend from England has come now to start basing on Krishnapatnam. Now every 50 kilometers there will be one port in Andhra Pradesh in the near future. That is our plan. So that I wanted to make it logistics hub. If you see water is available, even I can say my chief secretary, who is an energy secretary also, he had an abundant experience in energy. I started power sector reforms. He worked nearly 14 to 15 years in energy sector. No other IAS officer had knowledge about it. He had enough knowledge. With all these factors, what I wanted to announce here, even Andhra Pradesh wanted to contribute nearly 160 gigawatt capacity of green energy in the near future out of 500. This is the policy we have announced with 10 lakh crores investment and also 7.5 lakh employment and also green hydrogen and its derivatives 1.5 million metric tons per annum. Electrolyzer manufacturing capacity 3 gigawatt. Solar energy projects 78.5 gigawatts. Wind energy projects 35 gigawatt. Pumped storage energy 22 gigawatts. No other state is having this advantage. they may not have water or also hydrological balance also. Even we are going battery energy storage system 25 gigawatt forever. That is this is also needed as of today. Ethanol 15,000 kiloliters per day. Bio CNG, CBG 10,000 tons per day. Clean tech manufacturing 20 gigawatts. Mine module molecular. Even we are going electric vehicle charging infrastructure, nearly 500 stations. For this, we have given excellent incentives. You can go ahead. You can see incentives. Even incentives for electrolyzer manufacturing also one of the best policy. If anybody is giving better than us, you tell us, we will correct it, we will update it, we will provide all the incentives, number one incentives in the country. That is our commitment. So far, even so many companies have come. Even Reliance Industries has come. 500 compressed biogas plants. They are going to spend 65,000 crores. They are going to create 250,000 employment. Even Renew, largest RE complexes in the country was held in Guntakal. They are going to spend 22,000 crores and also 1.50 gigawatt renewable energy project along with one GWH PESS in 2 phases with the employment generation of 4,000. Even Power Renewable Energy Private Limited signed MOU. This is 7 gigawatt wind, solar, hybrid power projects with an annual estimated investment of 49,000 crores and employment potential of 33,000 employment. So this is where another company, AP, I told you already, NTPC and NetCap, Greenco also. Very interestingly, if you see history, in 83 my party announced fertilizer plant in Kakinada. Then one entrepreneur who is selected, KVK Raju, he started Nagarjuna Fertilizers. Today, Greenco has taken over that Nagarjuna Fertilizers. They are going ammonia. At that time, we have given fertilizer plant. Today, same premises they are converting into ammonia. That is the change we are doing. That is the change it is happening. As I rightly mentioned, we are having all advantages. Solar, even some states, some countries, they may have some advantage, sometimes some missing. In Andhra Pradesh, we are having all advantages. Solar, wind, pumped energy, even water is also important for pumped energy. So water is available. And at the same time, if you see further, ports are very, very important for exports. Even green hydrogen, we need water. We are having water. There is a problem, we are having sea also. We can use water from sea water also for conversion, all these things. That is plenty of water is available in Andhra Pradesh. With all these things today, I really appreciate SRM for conducting historical meeting in Amaravati. Why I am saying historical meeting? Recently, originally if you see, Hyderabad, I started high-tech city focusing IT. Recently in Amaravati, we started Quantum Valley focusing artificial intelligence. Now today, I am very happy. We are focusing Hydrogen Valley starting from here. One is Quantum Valley, quantum computing, technology with deep tech, everything. How to protect environment. There you need green energy and also downstream industries, total ecosystem. You can imagine if you can protect nature and you can use technology in a big way, sky is the limit for development. Or otherwise we'll have all problems. That is where two valleys are coming here. One is Quantum Valley for computing and also technology. One is Green Hydrogen Valley from here to protect nature for sustainability. That is very, very important. Here I am asking SRM. They have done good work. This is only the beginning. I am requesting SRM to take lead to bring industry, green hydrogen players who are all in the field, and also research organizations and all users. How to take to logical conclusion. Today, it is a matter of cost. If you scale up, and at the same time, if you can go for innovations, you are all here. Our youngsters are also here. Continuously you will think you will get so many solutions. How to get best solution for reducing the cost, thereby affordability. That is only a game changer. For this hydrogen storage, transportation, and so many things, we can work it out. There I am saying today, after today, tomorrow, all discussions will conclude. We will declare Amaravati Green Hydrogen Declaration 2025. Same day, next year, we will meet again to review what we have done, what is the progress. Bring knowledge available globally. Bring all experts and players available globally. And also we will improve further with value addition. If you can provide all solutions, I am here to give proof of concept. Some chief ministers may not understand, but our Prime Minister is very clear. He had a clarity in technology and also vision. That is where I am saying always, right time, right place, right person. That is Narendra Modi ji as on today. Now India is having very good advantages. I am telling you again and again. Reforms has been started in 1991. First more advantage in technology, that is 1995. Demographic dividend as a windfall gain. All other countries are facing a problem of aging, where India is able to provide capable and also very, very effective human resources to solve their problems. That is the strength of India today. Even some countries are depending on India for solving their problems or serving their community. India is having capacity to serve that. So with all advantages, I am appealing all of you, 2 days, have a good time, and also bring all innovative ideas and give it to us. We will implement it. We'll meet again next year, same time here. What we have done, proof of concept, and then scale it up, then replicate, then it will be model for the global community also. That is where we are going to do it. I'm very happy. This is very, very innovative summit and creative summit. Earlier, all education institutions means only teaching, only academic, not application. Even abroad, every university you are seeing, either Stanford, Harvard, or Purdue, so many universities, they are bringing all players together and they are giving solutions for the problem. We have spent so much of money, but always you have to keep it in mind. What we learn has to be used for outcomes. If you provide a proof of concept, then it is a reality. Otherwise, it is only a theory. Then you have to train again for providing proof of concept. Now in India also we are changing our approach. Our universities are doing very well, either IITs or universities like SRM and other universities are doing very well. I wanted to make Amaravati as an education hub for global knowledge. That is what I am thinking to promote here. SRM is here, WIT is here, SLRA has come, even BITS Pilani is here, Amma University is here. I wanted to bring other universities, globally the best universities. I am asking all universities to focus 3-4 subjects. Bring industry, research organizations, give a solution for the problems, solve the problems, then prepare use cases, we'll adopt it, we'll take forward. That is how all universities I want to use for solving the problems of the society what we are facing today. I am very happy SRM has taken lead. Even other universities are also working in that direction. We will encourage all universities who are all working in this direction and make use of their services in the near future. So with all these things, very, very important subject, critical subject. Future is only green hydrogen. It is a game changer. How to take logical conclusion? One is affordability. Second is cost effective. These two aspects, if you can break through, even I am asking all youngsters, they have to do innovative ideas, brainstorming with their colleagues, come to solutions. Even if you see today, Vijayawada and also Visakhapatnam are the best top 10 cities in India for having excellent skills. That is where reports are coming. In future, Andhra Pradesh will be the best state for entrepreneurship and also skills available in the country. That is what is going to happen in the near future. With all these things, really, I appreciate Mr. Satyanarayana, Pro-Chancellor, SRM, and Narayan Rao. Always he is pushing things. I wish him all the best. Once again, all members who are all assembled here, best of luck. I wish all the best. Thank you, one and all.
We are immensely grateful for having you here, sir, and for sharing your vision of positioning Andhra Pradesh at the forefront of the global green hydrogen revolution. we are gathered here today in this landmark occasion to witness the signing of the two transformative memorandums of understanding between the Government of Andhra Pradesh with Yamuna and JKSH and Hinfra. First, we welcome Mr. Gal Bogin, representing Yamuna, for their visionary 1 million ton per annum green ammonia project at Krishnapatnam with an investment of 16,000 crores. Next, we are honored to invite Mr. Tomoho Umeda, representing JKSH and Hinfra, for their ambitious project at Machilipatnam, comprising 150 KTPA green hydrogen and 600 KTPA green ammonia, with a massive investment of rupees 35,000 crores. Together, these initiatives are expected to generate approximately 10,500 employment opportunities, reinforcing Andhra Pradesh emergence as a global hub for sustainable energy innovation. These projects are being facilitated by Dr. M. Kamalakar Babu, Vice Chairman and Managing Director of NREDC AP, under the guidance of the Energy Department, Government of Andhra Pradesh. Let's now proceed to the ceremonial signing of the MOUs, symbolizing a shared commitment to clean energy, economic development, and the global collaboration. We kindly request Sri Nara Chandrababu Naidu Garu, Honorable Chief Minister of Andhra Pradesh, to felicitate Dr. V.K. Saraswat, Honorable Member, Niti Ayog. We kindly request Dr. P. Satyanarayanan, Pro-Chancellor, SRM University, Andhra Pradesh, to felicitate Sri Nara Chandrababu Naidu Garu, Honorable Chief Minister of Andhra Pradesh. We request Professor Satish Kumar, Pro Vice Chancellor, SRM University, Andhra Pradesh, to felicitate Dr. Chandrasekhar Pemasani, Honorable Minister of State for Rural Development and Communications, Government of India. We kindly request Sri Nara Chandrababu Naidu Garu, Honorable Chief Minister of Andhra Pradesh, to felicitate Dr. V.K. Saraswat, Honorable Member, Niti Ayog. We request Professor Satish Kumar, Pro Vice Chancellor, SRM University, Andhra Pradesh, to felicitate Dr. Sujit Pillai, Finest FMNRE. We request Professor D. Narayan Rao, Sir, Executive Director, Research, SRM Group of Institutions, to felicitate Dr. Ashish Lile, Director, CSIR, NCL, Pune. We request Professor D. Narayan Rao, Executive Director, Research, SRM Group of Institutions, to felicitate We request Professor D. Narayan Rao, Executive Director, Research, SRM Group of Institutions, to felicitate Dr. Ashish Lile, Director, CSIR, NCL, Pune. We request Professor D. Narayan Rao, Executive Director, Research, SRM Group of Institutions, to felicitate Dr. R.K. Malhotra, President, Hydrogen Association of India. We request Dr. P. Satyanarayanan, Pro-Chancellor, SRM University, Andhra Pradesh, to felicitate Mr. Pranav Tanti, President, CEO, Synergen Green Energy, USA. we request Dr. P. Satyanarayanan, Pro-Chancellor, SRM University, Andhra Pradesh, to felicitate Shri K. Vijayanand, Chief Secretary, Government of Andhra Pradesh. Finally, to conclude this inaugural session, we invite Dr. M. Kamalakar Babu, Vice Chairman and Managing Director, NREDC AP, Government of Andhra Pradesh, to deliver the vote of thanks.
Sir, on the occasion of Green Hydrogen Summit 2025 today, it's my privilege and honor to deliver the vote of thanks at this landmark and inspiring inauguration ceremony. Sir, first and foremost, I extend our deepest gratitude to Sri Nara Chandrababu Naidu Garu, Honorable Chief Minister of Andhra Pradesh, for his visionary leadership and Swarna Andhra Pradesh 2040 vision, 47 vision. His commitment to sustainable development and the transformative integrated clean energy policy 2024 has laid down the foundation of Andhra Pradesh to emerge as a national leader in green hydrogen and also renewable energy innovation. Under his guidance, the state is not only attracting massive investments, but also creating ready employment opportunities for lakhs of youth. Sir, we are very happy to, sir, your good selves have announced that Amravati Green Hydrogen Valley Declaration, sir. We work under your able guidance and will do the needful, sir. Sir, and also we are privileged to have Dr. K.V. Saraswati ji, Honorable Member, Niti Aayog, Government of India, with us today as the premier think tank of the Government of India. Niti Aayog continues to play a catalytic role in shaping India's clean energy and renewable energy roadmap. Our sincere thanks to Dr. Chandrasekhar Pemasani Garu, Honorable Minister for State Rural Development and Communications, Government of India, for his commitment and inclusive development and rural connectivity, and also he has given today an extensive insights in the field of green energy hydrogen summit, particularly for the benefit of the Andhra Pradesh. Sir, a special word of appreciation to Sri K. Vijayanand Garu, IAS Chief Secretary, Government of Andhra Pradesh, for his pivotal role in driving implementation of Andhra Pradesh Integrated Clean Energy Policy 2024. His administrative leadership and technical expertise in Energy Department has been instrumental in enabling the rapid progress of green hydrogen initiatives and fostering robust clean energy ecosystem in the state. We extend our heartfelt thanks to Dr. P. Satyanarayanan, Pro-Chancellor for SRM University, AP, for hosting the summit and for his vision in making SRM a center of excellence in clean energy, education and research. Sir, I will also extend my sincere thanks and gratitude to Dr. Sujit Pillai, MNRE, and also Dr. Malhotra, President, Hydrogen Association of India, Dr. Abhinav Thanti, President, Sujlan Green Energy, and also Professor Dr. Narayan Rao, Executive Director, SRM University, and also Professor Pathasarathi and Sujit Kolluri, who has given a very good insights and also work together with our things. And so, sir, to all the CEOs and industry leaders present, thank you very much for your commitment and to innovation and investment in Andhra Pradesh green hydrogen ecosystem. Your collaboration is vital to achieving our ambitious targets. We also wish to acknowledge the invaluable contribution to our organizing partners, SRM University, Andhra Pradesh, IIT Tirupati MNRE Government of India, NetCap. Your collective efforts have made the summit possible and impactful. To our sponsors and industry sponsors, thank you for your generous support and belief in your vision, sustainable future powered by green hydrogen. We sincerely extend our gratitude to press and electronic media, whose relentless service and also main pillars for the dissemination of the information to the entire state and country. We also express our sincere thanks to CMO officials and district administration for their time guidance to make this program successful. Finally, all the professors, students, esteemed guests, volunteers and dignitaries present here today, thank you for your enthusiasm, dedication and participation. Your presence marks the beginning of a transformative journey toward a greener tomorrow. Let us carry forward the momentum to today's inauguration, fostering deeper collaboration, driving policy innovation, and catalyzing strategic investments as we collectively shape the future of green hydrogen in Andhra Pradesh and beyond. Thanks everybody. Jai Hind, Jai Andhra Pradesh.
Please join us for a lunch break. We encourage you to use this time to connect with other participants and visit the booths in the exhibition area. Our volunteers will guide you. Please be here for the next session by 3:30 p.m. sharp. Kishore Kumar Hota is the CEO of NTPC UP Green Energy Limited, leading green energy initiatives for India's larger power utility. With over 30 years of experience in fuel security, gas sourcing, and project management, he previously served as an additional general manager for fuel security at NTPC. He holds a BSc in Mechanical Engineering from NIT Roorkela and PGDM from XIM Bhubaneswar. Mr. Hota plays a key role in advancing NTPC's transition to clean energy and sustainable power solutions. Over to you, sir.
That's synchronized? A very good afternoon. So I'm Kishore Hota from NTPC. So post-lunch is always a challenge for everyone, but I would like to make this session a little bit interesting, what all NTPC is doing. And in the morning session, we had a very, very enriched presentation, 3 presentations by the overall perspective, the green hydrogen and the clean hydrogen, from the Hydrogen Association as well as from the research perspective, what all things can be the possibility. Later on, we had an interaction, and I would really commend the initiatives of SRM and the government of Andhra Pradesh to organize such a beautiful on the subject, and the facilities has been really very good, and it is creating good interest. And seeing a chief minister of a progressive state sparing 4 hours of his valuable time with his top bureaucrats, so it really gives the importance. And I would proudly say we are also associated with the government of Andhra Pradesh as a partner, and we are investing a lot of money. And so I'll just start my presentation on the various initiatives of NTPC as far as green hydrogen is concerned. When the concept was introduced, much before the green hydrogen mission was conceptualized by the government, in the year 2019, we established the Department of Hydrogen in NTPC. hydrogen, and otherwise NTPC was primarily involved into the power generation, thermal, then hydro, then into the renewables. And as far as renewable is concerned, as you all know, we are a listed company, NTPC Green Energy Limited, wherein our targets are 60 gigawatts by the year 2030. And we are also developing nuclear plants, which is a high volume clean power. So coming to the various, this will be my outline of my presentation. As hydrogen was identified as a clean fuel for almost all the sector, including difficult sectors like various industries, transportation and all. So we started our initiative in different domains. I'd be talking something about the hydrogen mobility, wherein NTPC really took the initiative along with some other organizations like Indian Oil and say RIL. Prior to that, we also took some initiatives. Then recently, you might have heard about one microgrid got commissioned by Adani. So we are also taking up a very, very ambitious, very, very interesting microgrid project for the Indian Army. Then as far as hydrogen blending is concerned with the natural gas, we are one of the pioneer companies. We have established up to the 8% blending. And then Indian Railways is in the advanced stage of implementation of its locomotive. So are we going to implement our initiative of the hydrogen locomotive in our power plants. So that would be a very interesting project. And last but not the least, and which was talked in the morning mentioned by many. So we are putting up one of the first and hydrogen hubs, one of the biggest hydrogen hubs in the state of Andhra Pradesh. And coming to the mobility, this is, see, we got two mobility projects almost getting commissioned. The first one was at Leh, wherein we established the performance of the fuel cells by Ashok Leyland, operating at a elevation of 3,500 meter above the sea level, wherein you get very little oxygen, and we just tested the performance of the buses, and the buses performed better than the design. And I would proudly say, today we are operating 5 buses commercially in the territory of Ladakh, in various regions, some 3-4 circuits. So we have deployed 5 buses. That was an experimental project. This project was supported by the MNRE also. Certain funds are there. NTPC deployed its funds, and it is dedicated through a 1.7 gigawatt solar plant, and with we are producing around 80 kgs of green hydrogen every day, and feeding 5 buses. And we are the first company in India to establish the norms by the government, whether it's a 350 bar peso certification filling into the buses, and or even the number plate system. So that was also established. So we are, and the second project that is happening at our New Delhi, or say Greater Noida, so that's getting commissioned this month. So that is in advanced stage of commissioning, where we are again deploying 5 buses. These will be 12-meter buses. In the Leh one is 9-meter buses. And this will be a longer range, 600 kilometers each bus, so 3,000 kilometers a day. The Leh one was around 1,000 kilometers a day, 200 kilometers range each bus. So this was, if you see the lowermost peak, the Honorable Power Minister dedicated that, inaugurated that project in 2024. Then the buses were handed over last month. In the second peak, it was being handed over last month in 18th of June. Then after that, they have been successfully running. The buses are running in the market. So commercially it is running through बकायदा टिकट भी कटती है लोगों के, और 4 सर्किट में 4 circuits of Leh, Ladakh, that is getting serviced. So coming to the Greater Noida, all major equipments erected hai, LT gear switch is charged, civil commissioning by August, wherein we'll be operating in the Delhi Agra circuit that's being envisaged. So these are the pics of the facilities. Way forward. On the mobility aspect, we have gone beyond Greater Noida. We have, on the BO model, we have taken up with the government of Odisha, wherein we'll be operating operating 3 buses in maybe in the circuits of Puri, Konark, Bhubaneswar. Similarly, we have already with 2 ports, we are in advanced stage. One, the Kandla port, especially the port operations, whether it's a bus or the trucks and all. So we are in advanced stage in the Kandla part, and we are discussing with the Tuticorin port. And we are also part of the Hydrogen Valley at Jodhpur, wherein NTPC has been given the responsibility of this mobility as part of the total ecosystem of the Hydrogen Valley. This is the microgrid which I was talking about, wherein it's a very, very remote project in the Ladakh region near the Pangang Lake, which is not connected to the grid. So Indian Army is having an establishment which is being supplied by DG sets. The power is through DG sets through a microgrid. So we will be replacing the entire DG sets with having a dedicated solar plant of 3.2 megawatts. Then there is a PEM electrolyzer of 1 megawatt, and that is also a fuel cell at the end, 200 kilowatts. So that's a closed circuit, so which will be commissioned next year. So that's under implementation right now. And this is again a unique project which we are doing for Indian Army at the elevation of Ladakh. And this is about the green hydrogen blending to decarbonize the pipeline sector. Recently, there have been a task force report of CII how to really push the green hydrogen initiative when the cost is getting competitive over the years. In the morning, we discussed about the gray to blue to green and all. So that report recommended that certain percentage of the system be supported by the green. Supposing, say, we are running a gas pipeline with hydrogen and all, with the natural gas, which is CH4, methane, how that can be replaced or say blended hydrogen. And there have been success stories in many European countries, whether it's UK or say Germany or Netherlands. So they have been talking of hydrogen grids or say blending. Even there are some areas of Germany wherein certain clusters, they are being supplied 100% hydrogen in the old gas pipelines. So that way, they are establishing the embrittlement or the other technical aspects. So that is being closely studied. And NTPC is one of the first company wherein we took up with Gujarat Gas Limited. They had a connectivity with our own township at Kawas, with having a township of 200 households. And we generated the green power from, and we invested money, and that gas was blended initially at 2%, and at each stage we got the permission of the authorities, whether it's PESO or say PNGRB, because PNGRB is the gas regulator. And at each stage, tests were taken, all the technical data was submitted by GGL. Gradually, the permission was given to the 5%, then 8% points. So right now, that is getting established. And our next target is to go up to the 15%. And but that will be as per the roadmap which will be envisioned by the PNGRB. Recently, they have appointed a consultant who suggested them a roadmap, seeing the pilots which have been undertaken by various companies like NTPC or GAIL or Adani. So everybody is at different stages of blending. So similarly, when they have to modify their act, they have to go establish a pilot and all. So that is under implementation. So that is a step wherein we can really blend natural gas into the methane. Right. This is a very interesting project. Again, this will be the very first time in India. NTPC has super thermal power plants. There are 2 types. One is a peated plant, one is a non-peated plant. Peated plants are generally having a system called MGR, merry-go-round system, wherein the coal is sourced from the mine end. In a closed loop circuit, we are having our own track, own mini railway system, and those are generally diesel locomotives. And since Indian power plants are going to run for another 20 to 30 years, that's the target. So we also want to ourselves how we can green the system. So that way we are taken up a very, very ambitious project wherein our MGR also can be tried with a hydrogen locomotive. So that's in advanced stage of tendering, and the L1 has been already selected, and final negotiations are in progress, and that will be implemented very soon in Sipat, power project of NTPC, that's in Madhya Pradesh. So wherein it has got its own system, so those are the specifications. Fuel cells, hydrogen, it has got a dedicated solar plant. In fact, each plant of NTPC is targeting a net zero township. So we are having our own solar plants. So that way, solar power is available. Only we are putting the system of things, and the parties will be selected, is getting selected through competitive tendering process. And as far as Andhra is concerned, we have had a privilege of a very, very exotic location called Pudimadaka, which is around 20 kilometers down south of Vizag. So that land was available with us. That was around 1,200 acres of land, which was available with us. And with support of government of Andhra Pradesh, we are now dedicating for converting it to a green hydrogen hub, wherein we are developing, targeting to be like an SEZ, wherein we are developing the entire infrastructure, whether it's a green hydrogen supply or say green power supply or desalination plant, storage facilities, jetty facilities, construction power, startup water, sweet water, and everything. So the location is this. Then there is the airport is also very nearby. Vizag airport is also 40 kilometers, and the sea shore is only 2 kilometers. So wherein we will be having a desalination plant, we'll be taking additional 400 acres of land, wherein we'll be putting up our jetty facilities as well as the desalination plant. So this is one of the largest hubs of the world, and this was inaugurated by Honorable Prime Minister in January 2025. And this is one of the first hubs, and it is as per in line with the National Hydrogen Mission of India. So this is the exact Google location. You see the location in the map, and these are the projects. Basically the plant would be targeting producing green hydrogen of around 0.5 MMT, which will be converted into green ammonia of around 1,500 tons per day, that is around 2.5 MMT. Similarly, we are targeting green methanol around 0.5 MMT per annum, and similarly SAF. Other than these commercial projects, which would be developed by NTPC or by any other developer through a joint venture mode or any other different kind of mode, we are also having our demonstration projects. Our R&D wing called Netra, in the areas of the green hydrogen, so they have done a couple of projects. Like one of the project which was completed in Vindhyachal, which was one of its first of kind of its world, when we captured the flue gas from the captured the carbon dioxide from the flue gas, and we demonstrated a pilot green methanol plant. So that was successfully completed. Now the Netra wing of NTPC, they'll be having further demonstration plants of green ethanol, green urea, green SAF in the same location. So that way, that R&D activities, that technology demonstration activities, along with the commercial activities, are going to complete. And this, as far as the project is concerned, the project will be supplied again. We are having a joint venture with Andhra government, that the renewable arm of Andhra government, we are having a joint venture company, and we'll be producing around 20 gigawatts of, in the ultimate capacity, 20 gigawatts of green power to to power this hub, to produce this. Basically, the hub would be requiring around 7 gigawatts of RTC. So that will be, so we are having a target. So the initial 5,000 acres of land has already been identified. We are on first track of, with the support of the government of Andhra, we are putting up this power project. And this, in a nutshell, this project is of a mega size of 2.5 MMTPA. And the infrastructure is almost ready with the land, and especially the demonstration project. One of the project has been awarded already. So it has got the potential, and we are getting the DPR getting prepared by the World Bank. So that's, the discussions are already on, and we'll be selecting our partners very soon. And as far as demand potential is concerned, there is enough demand. Whether it's inside the country, NTPC has been participating in all the tenders. Whether it's a Indian Oil's green ammonia tender, where we are just 1 rupee below the winner, L&T. And similarly, we participated in the other refineries, whether HPCL, MRPL will be participating in the Numaligarh refinery and all. Recently, the SECI tender was also completed. So that way, NTPC is 100% dedicated and serious for this green molecule initiatives. And depending upon the feasibility and the locations, if it is near Pudimadaka, definitely we will put our plant in Pudimadaka also. So that way, it will be creating a stakeholder benefit of 57,000 employment in this region, and the ultimate investment in this particular hub, including the RE capacity, will be 1.85 lakh crores. So this is just this is a model vision of this. So you can see the jetty also. So that concludes my presentation. If there are any questions, I can take. Thank you so much. Thank you for your patient listening.
Thank you, sir, for painting a compelling picture of hydrogen's potential.
Sir, great vision and nice presentation. I really appreciate the vision of NTPC and the way you have presented. The couple of questions. We want to buy your buses. When you will be in a position to offer us, or what is the way of using your buses for our factory usage, for our staff movement?
In fact, we don't. The buses are generally. So far, we have taken the buses from Ashok Leyland through a competitive mechanism, and we are procuring the buses through a competitive tendering process, right? So the buses would be, obviously there are producers.
We approached most of them, but none of them ready to offer us. That is a challenge. And even we approached your team also. Unfortunately, as you rightly said, your team said, we are not making a buses, will be in a position to offer you. But when we approached Ashok Leyland, we approached all other manufacturers, they still not get an approval to run on the road. That is what they were keep saying.
No, they don't have the approval to run.
Yes, and they are not even offering.
Who is not? I didn't get your question.
AHRI, they need to go and then take an approval from them, still in a trial basis.
No, the buses are running. The buses are already running. Then already obviously, like say, for our New Delhi project, to operate the project, we need to have at least 20 certifications, 12 or 20 certifications. And as on date,
great. Can you connect us to them so that we can buy it from them?
No. I can give you the list of the certifications which you should be having to operate such a system. Right. So it's generally when we are going to say we will be operating in Bhubaneswar, that tendering is in tender stage. We are already finalized, right? So that way it will be on a BOO model. The Bhubaneswar model, or say Kandla model, or say the Tuticorin model, they are all on BOO model, wherein NTPC will put in the money and take back the money on a particular frequency of any monthly kind of returns.
Okay, sir. Thank you.
Thank you so much.
Thank you, sir, for painting a compelling picture of hydrogen's potential. Now, we request Dr. Parthasarathi Maram, Associate Professor, Department of Chemistry, and the convener of Green Hydrogen Summit, to present a memento to Dr. Kishore Kumar Hota. Now, we move forward to Conclave 1, the National Green Hydrogen Mission, role of governments, industry and academia. I invite Dr. M. Kamalakar Babu, Government of Andhra Pradesh, to preside this session, sir. Dr. Kamalakar Babu, Vice Chairman and Managing Director of NREDC AP and MD and CEO of APSPCL, is one of India's longest serving renewable energy administrators, driving Andhra Pradesh leadership in clean energy, solar parks, and EV infrastructure. With a multidisciplinary background in science, law, and energy governance, he has led transformative projects like 1000 MV Kurnool Ultra Mega Solar Park and received numerous national awards, including the Green Energy Champion Award in 2024. His visionary leadership has added over 6,500 megawatts of renewable capacity to the state and continues to shape India's clean energy future. Over to you, sir.
So welcome again to all my colleagues, panelists, industries, and also experts to have this National Green Hydrogen Summit. Yeah. So the panelists, Dr. S.S.V. Ramkumar, AM Green, Dr. Sujit Pillai, MNRE, Dr. Tata Narsingh Rao, IIT Hyderabad. So please, I invite you cordially to the dais to have your discussions and also things together. Yeah. So anybody who has interest in this topic, that is National Green Hydrogen Mission, role of governments, industry and academia. If anybody interested there, they are most welcome to be here to participate. Yeah, please come, Mr. Iyer, please come. I request Professor Iyer, IIT Mumbai. Yeah, NIT Kurukshetra, but you've done a lot of works in IIT Mumbai also, no? Yeah, please come. ఇక్కడే మనం చేయాలా? He is Mr. Mallikarjuna, Dr. Mallikarjuna Shakti Photons Limited. Sir, with respect to this National Green Hydrogen Mission, see, we would like to have the probable inputs to the audience over here is how the things would take place, and what are the National Green Hydrogen Mission shaping India's energy future in the next 10 to 15 years. Before that, I would like to request Mr. Sudhijit Pillai, just throw some light on the National Green Hydrogen Mission role of government. I request Mr. Pillai.
Can you hear me?
Yeah.
Yes? Okay. So, the government of India is committed to creating an enabling ecosystem for green hydrogen to thrive. Our vision is very clear: to make India a global hub for green hydrogen production, utilization, and export by 2030, if not earlier. To achieve this, we have set ambitious targets under the National Green Hydrogen Mission, aiming to produce 5 million metric tons of green hydrogen annually and attract investments worth over 8 lakh crores by 2030. The role of the government is to act as a catalyst, laying the foundation through policy frameworks, financial incentives, and infrastructure development. We have introduced initiatives like the Strategic Interventions for Green Hydrogen Transition, that's a SITE program, which provides subsidies for both green hydrogen production as well as electrolyzer production. Additionally, we are streamlining regulations, facilitating land allocation for renewable energy projects, and ensuring seamless integration of green hydrogen into our energy systems. Through the NGHM, we are also supporting R&D. We have just awarded 23 R&D projects. We are also supporting skill development to encourage new, as well as we are now planning to introduce a scheme which will encourage new startups and MSMEs. The government is also fostering international collaborations to leverage global expertise and markets. By partnering with friendly countries like Germany, Japan, Australia, and various other nations, we aim to establish India as a key player in the global green hydrogen value chain. Furthermore, we are also planning a number of discussions in the coming weeks and months to understand what the needs of the industry and other stakeholders are. Thank you.
Thank you. Thank you, Mr. Sujit. Your insights as per the policy, National Hydrogen Mission. But sir, this is also a momentum for the coming Hydrogen Declaration Valley, also, as already Honorable CMs have given in the afternoon. So I would request now how this would be shaped in terms of industrial, academia in the next 15 years. That would be challenge over here. So the academicians and the industries, now the panelists, would able to make out.
Hi, yeah. Can I?
Would make out the merely the future next 10 to 15 years, how this could be modeling and shaping with the ultimate use of the common man. So from your industrial side, you can speak, and from academia side, somebody, that means the experts can speak. Overall conclusion can be drawn for this purpose of else, because this now this discussion would also be joining into the hands of the Hydrogen Valley for today's we are preparing. So I would request you give the valuable suggestions to note down the things in a proper way.
Thank you. This is Dr. Mallikarjun. Before I become an entrepreneur, I was an academician. So I can talk in terms of as an academia aspect as well as the industrial aspect. So before bringing to the academia aspect, as the PLI scheme has been involved, where the industries can come in and kind of reverse engineer and have an indigenous technology so that industrially we will also grow in India. So when you actually ask about how the rural or everybody, the common people can get benefited. So the common people can actually get benefited from collecting the waste hydrocarbon. So now the municipality waste conversion into hydrogen or agricultural crop, anything waste which is converted into hydrogen, all these technologies are actually kind of connecting to the every citizen of the India. Because now, if the gasification kind of technologies are actually really coming into the each and every village, all the waste will not be lying on the streets. It will be collected because each and every waste will be valued at a very premium prices. And because the hydrogen is actually changing all that game, because the waste has a crucial amount of carbon monoxide and hydrogen, and that is converted into a value-added hydrocarbon, which is ethanol or a SAF, and that is only possible by segregating the local level waste. So where the every citizen of the India is pretty much cautious about holding the carbon atom and hydrogen atom from as a raw precursor for value-added product. As an academicians and governments is pretty much to make this happen the next 10 to 15 years to develop all the sector technologies, the electrolyzers. Now inside the electrolyzer there are so many concepts in which the catalyst development. Academicians are playing a crucial role in developing the cost-effective catalyst, cost-effective membranes. If you look at the electrolyzer, in the PEM electrolyzer, only DuPont is the only one company which is making the membrane. There is no other company who is actually coming into picture. So the academia will play a crucial role to develop alternative to Nefion membrane, alternative to piperidine membrane, alternative to Zirfon, which is the alkaline membrane. So these are all like big obstacles for research community. The academia is gonna tunnel into it and then develop something for Indian industry. I think that.
Fine. So, in nutshell, what are your actionable points in coming days, and how it could be incorporated in this Hydrogen Valley declaration?
Right. So then, let's say, for example, we can actually have research, very focused grants, research R&D grants for academia to develop cost-effective catalysts or cost-effective membranes and alternative to titanium grade 2 bipolar plates, and develop our own high-density graphite plates for the fuel cell, lightweight fuel cell, and minimize the platinum content in the fuel cell, bringing alternative platinum. This has been the research maybe 20, 30 years in Indian academia, but not as a focused, highly funded research. So majorly bringing up as each and every academician as a output-based product. So then maybe we will definitely discover. Recently, like a few weeks ago, a month ago in USA near NREL laboratory groups, they have developed a 20 ampere per square centimeter current density PEM electrolyzer operation. It is a game changer, which can actually minimize the cost of the electrolyzer even below the alkaline electrolyzer. So these kind of inventions only occur from the laboratories, academicians. So focused grants to academician, which will have an output which can come into the market, not as a publication. So that's the major kind of a motivation will bring it out.
Yeah. Thank you, Mr. Malik. So next, I move on to the same. What are the key milestones, success indicators we should look for during the implementation of the mission?
So, you want me to talk?
Yeah, please.
I am from academia because I am from IIT Hyderabad.
Okay then.
I was director of ARCA, which is DSTC Institute. After retirement, last year I moved as advisor to IIT Hyderabad. So, I will make very few points which are very important for next 10 to 15 years, what you said.
Yeah.
So, before that, I want to congratulate Professor Ashish Lele, because we both are on research advisory board of one of the DST institutes. And few years back, I was telling him when one of our central ministers drove the Toyota Mirai car, which is powered by PM fuel cell, and we are also working on fuel cells at ARCA. If you consider a 10 kilowatt stack, it is so big. So I used to wonder how these stacks will go into a car if you want to drive a car. So the stack size should be as small as possible. Then when the dream came true when we saw the Toyota Mirai, it is possible. Only thing is we have to work towards that. not just only working and showcasing a stake. That's okay. You show 20 kilowatt or 50 kilowatt stack, but the ultimate one comes because most of the hydrogen goes into the electric vehicle, not electric vehicle, mobility vehicle. That is, instead of fuel, you will have hydrogen. So PM fuel cell plays a very important role, as he also said. And Ashish Lele, I was asking Professor Ashish Lele that Ashish, kab hoga Toyota Mirai ka equivalent? And today, when I see Ashish Lele's car that is driven and he says 400 kilometers driving range, is wonderful. And then I think this is what we require. And in other areas also, there are some challenges which were not mentioned, partly mentioned. So that what are the solutions I just want, especially young people are there here. So there are so many opportunities for your research also. So first let me take, for the National Hydrogen Mission's goal of 500 million metric ton of hydrogen production by 2030. That is a very ambitious goal, which of course, the way we are going, will meet it. But when you say it's green hydrogen, majority of the green hydrogen is because of the solar. And then we have installed enough solar plants, and then now we have plenty of solar energy. And then we need to have almost double it if we want to meet this challenge. Then where are the solar panels? One of our speakers in the morning said that all solar panels, we may integrate within the country, but all silicon panels are being imported from China. So what is the way forward? Can we really keep buying? And then there will be a time where when the demand and supply goes wrong, then we will stop somewhere. So can we make our own silicon? That is also will take time because we could not make in last several years. So the only possibility what in Greenco is also involved is looking is that recycling of the silicon panels. Already from 2012 or 13, we started installing solar panels. Now more than 10 years, they don't work, and 10 or 12 or 15 years, and they are becoming obsolete. Now Greenco itself, company himself, they want some of these panels have to be recycled, and they are looking into recycle. What is the advantage of that one? You have pure silicon in the, majority of the material is pure silicon in the silicon panels. And can I take that silicon and then recycle back into the 7.9 to 10N? That means 99.999. That many N's you need. So that much purity is required for silicon. And there are technologies where electroslag refining, electrode refining, which is possible. Now the projects are coming. In fact, IIT Hyderabad, we kept a project to the Quad country funding with Australia's Finban to recycle this one. Because that is only the way which is easier for us to make within the country recycling. The second point is electrolysis. Electrolysis, whatever green hydrogen we are talking, that's all with the clean water. And then where is the clean water? India is already a water-stressed country. And without clean water, you cannot electrolyze. So now the efforts are there, which are not still very successful, is seawater electrolysis. Like Professor, our Honorable Minister said, Chandrababu Naidu garu said that we have a huge coastal line. Yes. So all seawater can be utilized. Either you have to desalinate and use that water, but that again adds cost to that one. And there is a huge opportunity. If you go through the literature, there are so many catalysts being developed, there are so many membranes being developed, and the electrolyte itself is being modified so that that becomes selective to the hydrogen and oxygen evolution, not compete with chloride or chlorate in the seawater. So that is one challenge what can be addressed, seawater electrolysis, where there is a lot of research scope is there. And I already said PVC recycling is very important because that is indirectly connected to your green hydrogen also, because recycling of PV to make solar panels back. And the next one is another hydrogen. See, the $2 per kg is what we're talking, that is the target, comparing with the gray hydrogen which is coming from the steam reforming of the methane. So if you want to compete that one, why you want to do steam reforming of methane? Can you do methane itself? Strip the hydrogen from methane, that is methane pyrolysis. And methane pyrolysis, what happens is, you rise the temperature and do it in inert atmosphere and strip the hydrogen out, and what is remaining is carbon. If you use the right catalyst, your carbon can be graphene, it can be carbon nanotube, and which has added value to that carbon itself, so that your cost of hydrogen will come down. So this is methane pyrolysis, is nothing new, but in India also we have to start doing that one. I hope maybe Ram Kumar Garu may give more light on that one. But I see there are at least 4 companies who are doing this methane pyrolysis elsewhere. One is the famous company, BASF in Germany, is already putting a pilot facility. And the other one is compressing the this one, hydrogen, at high pressure. The Toyota Mirai itself, they use type 4 cylinders where the hydrogen is kept at 750 bars. So, where do you get this type 4 cylinders? Right now, India is importing type 4 cylinders because type 4 cylinders are lightweight, and that will gain the mileage also because you are using lightweight. But what is inside? It is not metal. It is a high density polyethylene, is the lining, and then core wrapped with carbon fiber composite, and then again glass fiber composite. So these composites where carbon fiber play a critical role. In fact, in our defense system, we use a lot of carbon fiber, but all this carbon fiber is being imported. India doesn't make any carbon fiber. And when you want type 4 kind of cylinder, you need T700, T900 kind of carbon fiber, which has got high modulus and high strength. So the technology of carbon fiber, actually ARCI now is trying to set up a plant from Russia. We initiated during my time, and now that is going to become a pilot plant at ARCI. So carbon fibers and the composites are very important to use these cylinders for compressing the hydrogen type 4. Right now, type 4 technology is not there, maybe at research stage, and the industries should look for. So industry should look forward and encourage and fund to the research labs for seawater electrolysis, recycling of PV panels, and carbon fiber technology and composites for type 4 cylinders and methane pyrolysis. That's all. Thank you so much.
Thank you, sir. Thank you. Very happy to learn a lot of things from Dr. Narsingh Rao ji. Now that I would also request Mr. Ram Kumar ji, CTO of AM Graham. Sir, what are the key milestones or success indicators we should look for during the implementation of this mission? Because you are really on the job, so you would be the right person to give pros and cons of the things that is going to happen in your great endeavor. So we would like to hear the main success. What are the main pillars of the success to take up this thing, either in a financial model, or in the policy issues, or in the government support, or in the industry support, or any matter that would really entails the process.
So thank you very much, and good afternoon once again. So what are the critical success factors? That's what if I paraphrase your question, for the green hydrogen or green hydrogen economy. See, the first target, let's first understand the targets and then see what is the critical success factor. Long back, when green hydrogen paradigm has come onto the horizon, last 5 years back, there was a formula which was doing rounds. It was in the drawing rooms, in the academia, in the corporate boards, everywhere. This formula is there. This formula is known as 1-1-1 formula. $1 per 1 kg in 1 decade. That was the target. I think Ashish Lele is not here. He is also one of the architects of coining this formula, I was told. So how far we succeeded after 5 years or 6 years on this 1-1-1 formula? So from we haven't reached $1 a kg, that is for sure, for green hydrogen. But from $7 or $8 or somewhere in Europe to $12 a kg, I think India has the greatest potential. India alone has the greatest potential of at least nearing towards that, if not one, at least $2 to $3. Today AM Green and Greenco bets that in the next 5 years that we can produce green hydrogen, coupled with the advantage of stabilized renewable electricity. When I say stabilized means renewable electricity round the clock with a plant load factor of 80% for an electrolyzer, Greenco is a firm believer in producing green hydrogen, and it is extremely possible at $3 a kg. At $3 a kg. Today, the discovered price in the recent tender by the refinery tender is almost $4. So we're almost there. So that would be one of the critical success factor. When I was at Indian Oil R&D, when we were working on hydrogen for mobility through fuel cells, the fuel cell bus manufacturers, whether it is Tata Motors, Ashok Leyland or KPIT, these are the people who always perennially used to put this target to us that as a hydrogen producer, if you can make available fuel cell grade hydrogen, they are not talking about green hydrogen, but they are talking about fuel cell grade hydrogen. What do you mean by fuel cell grade hydrogen? It is 5.9 purity. When I say 5.9 purity, 99.9999, fourth decimal. That is the kind of purity that the PEM cells demand. So, first of all, at what cost we are going to produce that that kind of pure hydrogen, whether green, gray, blue, I don't enter into the debate of color. And secondly, what is the reality? Today, Ashish has unveiled his fuel cell car and bus. But 2 years back at IOC R&D, we conducted a study along with BCG, and if fuel cell mobility has to cut break even with diesel propulsion, do you understand? Diesel propulsion, that means a bus running on diesel and a bus running on hydrogen fed, that whether Andhra Pradesh Hydrogen Valley or any other hydrogen valley should have to reach that critical success factor. 1,000 fuel cell buses, and today a fuel cell bus costs anywhere between 6 to 8 crores, whereas a diesel bus costs you less than 1 crore. Less than 1 crore. Chinese fuel cell bus manufacturers, they supply quotes to Indian industry. At least I myself got a quotation from a Chinese manufacturer at 3 crores a bus, 12 meter long bus I'm talking. 3 crores, 12 meter long bus 2 years back. So what kind of race that we have to run to catch up China and to catch up the critical success factor for anybody to guess. I would also like to make one more comment. One of the critical success factors is the portability of hydrogen. Hydrogen need to be stored, hydrogen need to be compressed, then it has to be ported. If you want to become, as Honorable Prime Minister in National Green Hydrogen Mission, he envisaged that India has to become a global green hydrogen exporting hub. That means you should be producing green hydrogen in India and you should be in a position to supply it to all the global locations where the user locations are. So I think the transportation, whether it is through pipeline or whether it is through liquid organic hydrogen carriers, LOHCs. So for academia, since I'm speaking on an academic platform, I would like to call upon all the researchers, because when I was heading the R&D of Indian Oil Corporation, I treated this as one of the key research area of very high importance if we want to really moderate the hydrogen costs, delivered costs of green hydrogen. So I think academia is very well equipped. The chemists are very well equipped to perfect the synthesis, discovery, and scale up of liquid organic hydrogen carriers, starting from as simple a molecule as toluene. Because hydrogenation and dehydrogenation technologies are very well there. The catalyst technology is very well evolved. So I think it is high time the academia should focus on this particular aspect so that for every location you can't lay a pipeline because pipeline requires the current pipeline metallurgy in India or in the world can support only 20% infusion of hydrogen because of embrittlement problem of hydrogen. So either you have to lay a dedicated hydrogen pipeline with extremely curated metallurgy, steel metallurgy, which would be robust enough to take care of the embrittlement problem, or the simplest way is put a hydrogenation plant at the source of generation, infuse the hydrogen into a good molecule, ideal molecule, take that molecule in liquid form to whichever destination you want, you just dehydrogenate and recover the hydrogen. That is the principle. There will be some losses associated with both the steps, but these losses can still be compensated if the molecule is cost effective, economically viable, and portable, easily portable. So I feel this as one of the critical success factors. And in fuel cell also, at least Indian Oil R&D, for 5 years it has been working that why do you need 5.9 purity of hydrogen to run a fuel cell, a PEM fuel cell? Can we run a PEM fuel cell on hydrogen which is on as is, where is basis? Whether you produce through SMR, whether you produce, of course, electrolyzer, it will give you relatively very high pure hydrogen, but even gasification, biomass gasification or petcoke gasification, coal gasification or SMR hydrogen, they all give you 95% purity or 96% purity. So you need to jack up the purity from 96 or 95 to 99. So can we run a PEM fuel cell with 95% pure hydrogen? This is the question that we asked ourselves at IOC R&D, and we achieved a lot of success of using it and maintaining the fuel cell efficiency. I'm sure Indian Oil in the last 2 years when I left the system, they must have continued their work and actually scaled up this phenomena. It is, I can share this is already patented, so I can share this. The phenomena that we used to use impure hydrogen to run a PEM fuel cell is through pulse oxidation mechanism. So I think I'll stop here. There are several such critical success factors that one can enumerate. I'm sure in the years to come, many schools of academia and industrial R&D will be working on these targets to reach those success factors. Thank you.
Yeah, thank you, sir. We're highlighting the things which are really what you call value added with all your experiences, and also you've gone the actual process and the both pros and cons of the situation. Thank you very much. And then the last but one question, because I will ask one question to our friend Mr. Professor Iyer. So after that, the another question is to our MNRE dignitary, Mr. Sujit Pillai. So first, let me ask the question. See, sir, Professor Saab, what are the key technical and financial barriers? Because for industries in adopting green hydrogen at scale, because you will moving around both government and industrial and private organizations, both in academician and an industrialist, and also a fund manager. I would like to throw some light on this now we have discussed. Kindly.
Yeah, so first let me introduce I am the president of the Renewable Energy Promotion Association, as well as I am Honorary Associate Dean for the New Delhi Institute of Management, a very unique experiment where we are trying to bring to the students post-graduation renewable energy. So this has been done by this institute first time in the country because there are a lot of skill development programs running, but we do it differently. Now, coming to your question, basically, I traveled in 2009. I was sponsored by the Canadian government, and I went to this Alberta, and I traveled on a 200 bhp truck with a reformer technology. They took me all around the highway. So I had experienced this reformer technology of Ballard. Ballard was the company that did, and I went to Ballard also. So it was already operating, so hydrogen is not new. Another thing I wish to state to you that I headed MAN for years together before I came into the non-profits. And my last assignment was MAN B&W. So we had already powered our engines for marine propulsion, as well as possible power generation with hydrogen. The only problem was beyond 25%, our director there, a very research-oriented man, von Lüttischau, he was very clear that we could not do more than 25 at the time. We had blended 25% hydrogen in a conventional IC engine producing power. 1 megawatt was per cylinder. That much powerful those engines are. So we had put about 4,000 megawatt of captive power in this country, and we beat China at that time. So these are histories not known. And these are, right in Andhra Pradesh, we had at Tadpatri 12 megawatt power plants running on HFO in those days. But those very engines could operate on, and I have visited Augsburg and seen the technology. Then my friend Anders Jensen, because since you opened such a thing, it's a very interesting thing.
Yeah, technical and financial barriers.
I'll come to financial. Anders Jensen, he came to India about 10 years back. Then he told, Professor, we're ready with the 2-stroke technology with hydrogen and the 4-stroke at MANES. So that is the interesting news I'm telling you, that this can be commercialized, and I believe hydrogen direct combustion will come beyond the fuel cell. So keep watching what I'm saying. Already there is, JCB has come out with a technology where they are already having the machines which can run in the construction industry using hydrogen. So probably we are discussing too slow. We see that it will be tomorrow, but it was yesterday, I think so. So that is one answer I want to give you, that hydrogen is surely here. Okay, it's right around the corner. The only point is whether we will accept a cost of $3 or not. So he rightfully said, Ramkumar Saab, ki practically we have to go to that $3 thing. Electricity costs also are going to increase. I am paying 15 rupees a unit for electricity in Dombivli in Maharashtra. So I tell you, for this, I want to approach the regulator that Attak to Kattak, Kashmir to Kanyakumari, why don't they have one domestic tariff? One grid ka meaning kya hai? We should not see, we are a lot of dichotomy we are living in. So we have to come to the same thing on hydrogen. So are we serious about giving affordable hydrogen? Because the UN SDG goals are about affordability. The word is affordable electricity, affordable hydrogen. 100% project financing without margin money will be available. That will be available flat at 2.5%. It will destroy whatever is being thought about in the past. And also, if PPP is there will be partnership in finance. But all these interest will come from these institutions, which are new, massive funds, which will only come provided we are viable commercially. There is a business case for it. So right now, just doing blending in some CNG system and city gas, this is not what I will suggest, because MNRE, our friend, is here. So please don't do this small tweaking. Sab kaam nahi kariye. See, let's go to the huge build-up of volume. It's the same thing I did in Gujarat. I was, that time everybody was against me. Maheshwar Sahu was on the dais, 2011 in Amalthea of IIT Gandhinagar. I said 5 rupees per unit and 5 crore per megawatt. I was a villain in that, but I introduced the career of a journalist there, because I mentored her and brought her from Rajdeep's place, Yogita Leme, and she conducted that program. And after that, Sahu Saab, just like you, chairing today, he said only one man here knew what was happening, as the Professor Iyer. And we came to the price of 3 rupees for solar only because of such moves. Shyam Saranji was the first man who encouraged me on that. So I can tell you that we are old, the same people. Like last year, you remember, Garu, you remember very well how we pushed the pump storage. The moment I brought it and went to Delhi, met my friends in MOP and CA, what is happening to pump storage? Yes, within 1 year, nobody was ready to bell the cat. That white paper has changed the dimension, and it was Andhra which is leading. Today, I'm telling you, friends, Andhra is the only state with 24 gigawatt plus being ordered after DPR and under execution under NREDCAP, under his chairmanship now. So if this is the volume we need to, so you are not new to this, sir. You have performed, and I would only say sky is not the limit. Please let us open our gates. Let's collaborate with world leaders. There are a lot of university collaboration is possible. I can tell you in other areas also. I can bring to you in India a 29% efficient cell material in solar, because you need to put a lot of solar, right? So if Andhra is ready, I will get you that from Alberta. Basically, that is called phenylsilane. We published this article more than a decade ago. So this is what I am telling you. Everything is on the dot. It's not tomorrow, it is yesterday. So we are in the hydrogen, we are discussing this. I saw it in 2009. I saw the operation of the 200 bhp. We didn't have a 40 bhp truck in India. We still don't make engines, sir. The only engine that is purely Indian designed engine is from the Durgapur Institute, operated in that tractor in Sonalika tractor. Other than that, we have no engines. It's all Cummins and all these fellows. So where is the engine coming from any mechanical institution? Let's prepare an IC engine and let us run it on CBG. Again, the white paper on CBG was 2020. Thanks to Tarun Kapoor, it was pandemic. He said, Iyer Saab, nobody is doing this satat hamara. वो तो 18 में अच्छा policy था, कुछ करिए. We created a white paper in 2021. Look at today, we are celebrating on 6th August, and I have invited you. You are our star for solar and other things. 108 plants are operating today, sir, for CPG. And he made a good point on the purification. So their Evonik membranes were used. They are my patrons. It's a company which is not bothered, but they have the membrane technology for hydrogen also. So we are looking at things which are very futuristic. Nothing is, and we have to adopt. See what we have to do, we have to take technology and we should control the fuel. Like even in nuclear, I just put a parting word for you. Even for nuclear, we have to go to small modular thorium reactors. We should be controlling the fuel. Even if we have to import the technology, it's fine. Thank you, sir.
Thank you, Professor Saab. So before we close the our panel conclave, the last question I would like to ask Mr. Pillai. That means since we are in government, see what is the scope for policy regulation framework are essential to accelerate green hydrogen adoption in India. See what are the way forward. Can you throw any light on as a central organization, so that any state also would definitely follow that organization, that directions to accelerate, because there is a lot of targets have been given by the states, particularly in Andhra Pradesh. So what are that really the policy regulatory frameworks that would really enhance the green hydrogen adoption in India?
For this, I cannot comment on any policies that we are right now framing or will frame, because that would not be proper. But what I can say is there was recently a CI conclave on August, I believe it was this last month, in which I won't take the name of the company, but one of the consultancy firms that published a report talking about how to increase the demand for green hydrogen in India. So that maybe that is something that can be referred to, where they said that one of the things, of course, yeah, maybe Dr. Ramkumar wants to.
Sorry, intruding you. Just when national roadmap for national green hydrogen mission was still in drafting stage, various industries were notified by governments or their respective ministries. I was at Indian Oil, and Ministry of Petroleum has asked big companies like us, other companies, how we are going to react to a policy called Green Hydrogen Consumption Obligation, GHCO, Green Hydrogen Consumption Obligation. So each of us have done a lot of calculations, lot of maths. What is going to be the impact of our products, the gasoline and diesel that we are going to sell, if suppose 10% green hydrogen out of the total hydrogen that we use, because hydrogen is the lifeline of a refinery. Hydrogen is the pivotal ingredient for producing the petroleum products. So out of the total gray hydrogen predominantly that we use today, if suppose X percentage of hydrogen, if we convert and replace it with the green hydrogen, what is the impact? I think each one of us, each oil company has worked on that. Similarly, the fertilizer, there are 3 sectors which were identified, and they were asked to be prepared for this GHCO. Though this has never been a reality, finally when the mission was unveiled, this policy was never a reality. It was never announced by the government, but still every now and then government still is thinking very seriously. If we know the thought process of the government of India through various ministries, they have not still set curtains to this GHCO. In fact, in the National Green Hydrogen Mission, whatever hydrogen hubs originally thought of were only to kickstart the demand. But now those hubs policy has been reconverted into HVIC. I was a part of that HVIC project appraisal committee right now, which is spearheaded by DST. So these are Hydrogen Valley Innovation Clusters. Instead of hubs, the government, the MNRE and DST now join hands, and 4 HVICs have been identified and awarded at each at a cost of few 100 crores of rupees. I don't precisely give that. So demand creation to start with will happen unless there should be some, at least in the regulated and controlled sectors, you should have some consumption obligation. This is purely my personal opinion, but definitely I think there is a rethink on the part of the government to reintroduce or introduce. They have never introduced it, but now they want to reintroduce the green hydrogen consumption obligations. The numbers need to be negotiated, numbers need to be worked out. For refineries, it may be 20%, for fertilizers, it may be 10%. Nobody knows this, but everybody has worked out. Everybody has worked out what if it is 20%, what if it is 10%, what kind of financial implications with the current costs of green hydrogen that it works out to be on a national exchequer level. These figures are ready with each big company. But when the policy will come, Dr. Malhotra, as President of Hydrogen Association of India, is smiling at us. But I sincerely believe that this should be the demand creation.
I'd also like to add one thing, like as far as demand obligation is concerned, I think a few countries have introduced it. For example, I believe Netherlands has introduced such. So maybe Dr. Ramkumar, you can talk about the Netherlands. But I believe it's very small.
No, let Sujit tell that.
No, boliye sir, boliye.
No, the issue is that when you are saying obligation, now you are sitting not in an oil company side, but on a green hydrogen producer side. You know, the refiners and fertilizer industry, which you mentioned could have been one of the obligatory buyers of green hydrogen. You know, refineries have been saying that the prices of products will increase, which you also know. By how much also, I also know, and you also know. But these figures are not much. But the point is, in fact, one of the empowered group of Green Hydrogen Mission, where I am a member, last meeting, cabinet, I don't know whether it is appropriate to mention the proceeding. Maybe not. So I will not talk about it. So, chhod dijiye usko. So there are issues, there are concerns by the refineries which have been expressed. Refineries have a doubt whether the increase will be allowed to be passed on or not. That is another issue. Fertilizer industry is actually already subsidized. And if they have to use hydrogen, which is more expensive, the government subsidy will have to increase. Government gives subsidy for electrolyzer manufacturing, government gives subsidy for green hydrogen production. If government starts giving subsidy for increased subsidy to fertilizer industry for use of green hydrogen, I think the government also has limitations. You must understand that. Now the second point, I agree with you that the demand has to be created. Now the Bureau of Energy Efficiency has come out with a carbon credits obligatory, compliance markets, where some of the 13 type of industries have been listed as under the compliance mechanism. And those companies will be obligatory for them, to decarbonize. And hydrogen, green hydrogen is one of the enabler for decarbonization. So look at from that point of view. Every time it should not be, things should not be forcible. You have said that, okay, industry has to decarbonize, let them use. Then they will have to buy, either they do it through their energy efficiency route, or they reduce their carbon footprint through use of green hydrogen for decarbonization. They'll leave it to them. See, these kind of subsidy regimes, Dr. Ramkumar, and forcing some industry, the green hydrogen production cost has to come down. You said it has come down. It needs to come down. Don't expect government. I'm speaking on behalf of the government. I'm not part of the government, but I sit on the important committee for National Green Hydrogen Mission. I'm just conveying the sentiments of the government that subsidy cannot be there for everything. Look at electrolyzer, you agree, are being subsidized. There is a scheme for green hydrogen subsidy. Now,
Sir, I'm not asking subsidy from the government. In fact, my current company
but
looked for subsidy.
Government,
it is a consumption obligation. That's what I'm saying.
I don't want to get into a debate on this, but the point is that the government has already allocated. Maybe your company is not taking, but somebody else is taking for electrolyzer manufacturing. Somebody is taking money for green hydrogen subsidy also. A fund has been allocated. The government cannot be allocating funds for each subsidy. That's the fertilizer industry. The oil industry is going. They are going to produce their own green hydrogen, and whatever percentage they said, okay, we'll not buy, we'll do it of our own. And if the targets are going to be defined, they will do it. Either they will buy or they will do it themselves. Even if they do it themselves, they need not buy from AM Green or Green Code. They will produce it themselves. There's nothing wrong in it. So they are decarbonizing their part of the, So this is a matter which is, refinery said we'll do it ourselves. We don't want to buy costly.
Sir, there was a renewable portfolio obligation, if all missed that out. This came out, and that's why huge renewable has come in. So the devil's advocate is here. So similarly, there must be some consumption.
So, well done, sir. Thank you very much for this first conclave. The role of government and industries and academia for the targets given by the National Hydrogen Mission. And then I thank you, everybody have given a wonderful insights how to move out particularly this aspect in the green hydrogen. So thank you for this. We'll take up the other session till such time from the organizer side. I thank you very much for your presence, wonderful presentation, and our valuable presence. Thank you, sir. Thank you.
Thank you, sir. Thank you to all our panelists and moderators for this engaging and collaborative discussion. We request Dr. M. Kamalakar Babu to felicitate Dr. Tata Narsingh Rao and Sri Gopal Krishna Iyer from REPA. I also request him to present a bouquet to Dr. Mallikarjuna from Shakti Photons Private Limited. Thank you, sir. Thank you very much. We now move on to Conclave 2. For this, I request Dr. Sujit Pillai, NHM MNRE, Government of India, to kindly moderate the session and welcome the panelists, sir. Dr. Sujit Pillai, scientist at MNRE, a driving force behind India's clean energy revolution with expertise spanning solar innovation, hydrogen policy, and technology integration. His leadership bridges cutting-edge research and impactful policy. His presence reflects MNRE's bold vision for a sustainable collaborative energy future. Over to you, sir.
Hello. Yes, good evening. Welcome to Conclave 2, which is a panel discussion on when will India fully utilize the real-world applications of green hydrogen and what steps must the Indian government take. So I invite Dr. R.K. Malhotra, sir, and Mr. Robbie Rajashekharan of KPI Green, Mr. Gal Bogin of Yamna, and also Mr. Shailendra Bebortha, and okay, Shri P.C. Garg from NSCFI, and Mr. Harish Jairam from Hygenco. You are? So first, let me introduce the panelists. Dr. R.K. Malhotra, President of the Hydrogen Association of India, is a renowned energy expert with over 48 years of experience in fuels, hydrogen, and automotive technology. A PhD from IIT Delhi, he has held key leadership roles in Indian Oil Corporation, FIPI, and national policy bodies, and has authored more than 200 papers with 138 patents. He has received global accolades, including the Hart Energy Global Award for his pioneering work in renewable energy and hydrogen research. Welcome, sir. Okay. Now I move to Mr. Robbie Rajashekharam. Okay. He is the Chief Executive Officer of KPI Green Hydrogen and Ammonia Private Limited in Surat, I believe. Okay. Leading the KP Group's transition into the global hydrogen economy through strategic direction, technology innovation, and global partnerships. An alumnus of IIM Lucknow and Cambridge with project management credentials from NICMAR, he has led major infrastructure projects across solar, thermal, petrochemical, hospitality, and commercial sectors. His multifaceted background and commitment to decarbonizing energy-intensive industries make him a key driver in India's clean energy transition. Welcome, sir. Now, Mr. Shailendra. Mr. Shailendra Bebortha has 2 decades of experience in the renewable energy sector, cross-technology expertise in wind, solar, biomass, and small hydro projects. Currently the country representative for Scatec Solar. He has held CXO and board-level roles at Enercon, Conergy, REC Sunborn, and IBC Solar, specializing in strategy, fundraising, and full profit and loss management. Recognized among India's top 100 solar business leaders, his work integrates global best practices with local needs to drive clean energy growth and sustainability. Welcome, sir. We now have Shri P.C. Garg. Garg is the Honorary Principal Advisor of National Solar Energy Federation of India, NSCFI, with 37 years of distinguished service in the power sector, including leadership roles at CTU, Power Grid, and NTPC. As former CEO of CTU, he enabled large-scale renewable grid integration through ISTS planning, open access approvals, and advanced grid technologies like VSC-based HVDC and STATCOMs. A key figure in policy advocacy and transmission sector reforms, his expertise supports India's vision of integrating 500 gigawatt of renewables by 2030. And finally, welcome, sir. Finally, Mr. Harish Jairam is Vice President of Business Development at Hygenco Green Energies, driving global green hydrogen, ammonia, and biofuel-powered industrial solutions. With a background in mechanical and industrial engineering and an MBA in finance, he has led renewable energy development across multiple regions, including over 1 gigawatt of projects at Suryadesh Energy and leadership roles at Sun Edison. His expertise in decarbonizing hard-to-abate sectors and structuring scalable green hydrogen projects positions him at the forefront of India's clean energy transition. Welcome, sir. So now I will just start off by asking each one of you to make your opening statements on when, the question is, when will India fully utilize the real-world applications of green hydrogen? So an opening statement for maybe a few minutes. Let's start, Mr. R.K. Malhotra ji. Mr. Jairam, Mr. Robbie Rajashekharam.
Yeah. Good evening, everyone. Thank you so much, sir, for asking me to start this wonderful discussion. It's like we are, we heard a lot of things from academicians and then a lot of scholars who spoke about how the technology can bring in. But I'm again representing an industry, purely an industry, neither I came from academia or not from research background. But we always talk about business. We always look at a business. And the way we are looking at today, we are finding a lot of creative ways of, understanding whether can we reach the price of a green hydrogen, something close to green hydrogen. A lot of people may ask me a question, is it really possible? We are looking at, as someone said in the, before session, we are not just talking about the cost of hydrogen at the plant. We are talking about a delivery point. So we found a different interesting ways and means of, making this green hydrogen at the delivering point cost. See, a lot of times we all understand the green hydrogen production is some cost, and then transportation is a huge cost in India. Because you need to compress it, you need to transport it, everything involves money. But the route in which what we were looking at is, we are finding another way of transporting energy to the spot. So what we were looking at is another route by which the grid is well established in India. Today you'll be surprised to see the biggest grid in the world is India, second biggest grid is in India. So now we are trying to take the electricity to the spot, maybe a fuel station, there convert into hydrogen and dispense. So to my surprise, and the delta between gray hydrogen and green hydrogen drastically reducing. So my estimate goes, if this such an innovative ideas and then things goes on, maybe we can see the 2028 and 29 probably will have the green hydrogen par with, or probably will be in a position to 100% utilize them. This is my response, sir.
Okay, thank you. I now move to Mr. Shailendra. Shailendra, please, your opening statement, please.
Thank you, Sujit. First of all, thanks SRM University for inviting us to this conference. My name is Shailendra Vibhorta. I think the introduction was a bit dated. Right now, I'm here to represent Yamna as the country head of Yamna. And interestingly, we have signed a very interesting MOU with NetCap earlier today in the presence of Honorable Chief Minister to develop a large-scale green ammonia project in this state. So coming back to this topic, this dates me back to around 15 years back. In 2010, people were asking us a similar question on solar. That when we were sort of signing PPAs at 15 rupees tariff, the question is, when will general people be able to use solar power at say 2 rupees or 3 rupees? Right? It has taken 15 years and we've reached that stage. So I think we are facing the same question with respect to green hydrogen and ammonia. Now, if I look at the applications of green hydrogen, the immediate user cases seems to be power sector, followed by fertilizer, oil and gas, and steel and aluminum. These are the 4 sectors. Of course, there are numerous applications of hydrogen. Of course, I have not included mobility into it right now. Okay. So in terms of derivatives, these are the applications. And out of these 4, that the main ones that sort of we have identified, top 3 that we spoke of, power, fertilizer, and oil and gas, they are regulated markets in India, right? Where the price is not determined by the market forces, but this is regulated and this is as well as sometimes political. So given this stage and given the kind of federal policy that we have in India, I believe the initial development of these molecules will be aimed at decarbonizing overseas economies, exports, because in that case, a part of the cost structure will be compensated by the off-takers, right? Today, for example, you have markets like Japan, Korea, where they've got this CFD kind of scheme, effectively subsidizing the purchase of green hydrogen and green derivatives. So effectively, the additional impact of decarbonization from gray to green is partly done by states like Andhra Pradesh, countries like India, and partly by off-takers as well. So I think that would be the first phase. And by doing this first phase successfully, we will reach a stage where we'll be able to cut down the cost. And we have all our ambitions. People are talking about $2, $1. We will reach there because economics scale will there, the cost of financing will gradually come down. People have a more confidence in technology. And that's where perhaps the sector, the domestic user cases would improve. Till that time, of course, at the same time, I will not discount or rather the smaller initiatives which is being started by oil and gas companies in India. And these will be the projects which will sort of set up benchmarks, technical standards, certification standards. So this is a parallel process which will carry on. And at the same time, the global hydrogen costs have to come down to make a case for Indian domestic user cases. Thank you.
Mr. Garg, please.
Thank you. Thank you, Dr. Sujit. And first of all, I would like to convey my sincere thanks to the organizers for making such a wonderful arrangement and inviting me to participate in very, very important summit. I'll put a few landmarks or few datas which are very important in deciding when we will be able to harness this green hydrogen in real sense in our country, India. As we know that our country has set a renewable energy, or rather we can say the non-fossil fuel installed capacity target of 500 gigawatt by 2030 and net zero by 2070. Now this 500 gigawatt is doing well, but as we all know that solar is available in the daytime and wind is available maybe in different time of the day, but it is seasonal also. So certainly without having any kind of storage arrangement, we can't sustain with the renewable energy, and definitely the 2070 target cannot be fulfilled. So for this purpose, we need storage. Storage, of course, pump storage is there, BAS is there, but again, there has to be a mix of many provisions. Then only we can really go for a net zero by 2070. Now, green hydrogen is the right solution which can be adopted at scale. It can replace the energy input to the hard to abate sectors like steel, fertilizer industry, and of course the mobility is also very important. In mobility, a lot of fossil fuel is being consumed in India in mobility. So it has to replace fossil fuel in mobility sector also. In the during the inaugural session, we heard from Andhra that they are launching a green hydrogen drone mission. So drones will also run on green hydrogen. So we can just think of that we are planning use of green hydrogen in big way in almost all the sectors. For green hydrogen, India, the government of India, the central sector is doing a lot. We all know that initially we have thought of producing green hydrogen for export purpose. As he said, that is very necessary to do it in the beginning. And for that purpose, we have already taken, since I was in CTU earlier, so we have under guidance of MNRE, we have taken call for developing ISTS drawl points at different ports, like in Gujarat, Mundra, Kandla, Tamil Nadu, Tuticorin, Andhra Pradesh, Vizag port, and many other, Srikakulam and something like that, Krishnapatnam, and in Odisha, Paradeep. So all these ports have been identified and ISTS drawl points are being developed. At every port point, approximately 9 gigawatt of renewable energy will be made available for green hydrogen production. So certainly things are moving in the right direction. National Green Hydrogen Mission, approximately 20,000 crores of outlay, and the initiatives by states like Andhra, 1 million metric ton of green hydrogen production target, 20% of India's target of 5 million metric tons of green hydrogen by 2030. Then a lot of incentives like SGST waiver, 50% waiver of ISTS charges for RE drawn for green hydrogen production. So if we consider all these things, then definitely I am sure that by 2040, we must be in the same position, or rather in the better position as we are today for solar and wind. That's all. Thank you.
Thank you. Mrs. Jairam, opening statement.
Thank you, Mr. Pillai. First, like to thank the organizers, SRM University, Dr. Professor D.N. Rao here, Government of Andhra Pradesh. This is a fabulous auditorium. Very happy to be here. And thanks to my fellow colleagues on this panel. So the question is, when will India fully utilize the real-world applications of green hydrogen? So I want to say India is now definitely a brighter spot in the global scenario. I've seen ample traction demand triggers in the last 6 months, starting with the NTPC setting up the large, in fact, they're saying is the world's largest green hydrogen hub in the state of Andhra Pradesh. This happened early this year in Jan. And then we had price discovery happen in a couple of refining tenders, one which came from IOCL 2 months back, and then this month recently one more price discovery happened from HPCL. So all these are bright spots. And then last week, I think it was last Thursday, Friday, SECI closed the largest green ammonia tender. Capacity was about 724 KTPA. And all these are good validation and a sign of good things to come. If you look at the National Green Hydrogen Mission, it was split into 2 phases. Phase 1 was from year 23 to 26. The focus was on refinery, fertilizer, and also blending. I must say we've done fairly well in refinery with the tenders being awarded, done well on ammonia, tenders being awarded very soon. Blending, we still have some work to do, but earlier we heard from NTPC that we already have done 8% blending, and proposal of 15% has been put forward to the ministry. So all these are good signs. In the next phase, 26 to 30, the focus will be on new sectors. Green steel is one. Mobility. Shipping is going to be very interesting. So all of you have heard about IMO regulations which came out in the month of April. And with those regulations, I think there'll be a lot more focus on biofuels, focus on green ammonia, focus on green methanol. So the next 4 years in the second phase of the mission, there'll be ample focus on mobility, shipping, aviation, green steel, and along with focus on refinery fertilizers. I'm sure India will definitely meet the target of 5 million tons by year 2030. I'm sure we'll probably also exceed that. And let me add to it, how do we hit that? I think it'll be a combination of serving domestic demand. Of the 5, I would say probably about 40% will be domestic demand, and the balance would be exports. So 2 MTA would be domestic, and the balance 3 would be exports. And we'll also go beyond that. And definitely, I think India is on the right track, making all the right noise, doing all the right things, and with the government support from the center and the state support, especially this state of AP has done very, very well. This state has ample RE resources, has all the ports, has 6 ports, of which I think 3 or 4 are the large ports, has about 7 ports in the making, and good policy support from the government. Leadership has a vision. All these combined, all these factors will definitely hit our targets in 2030.
Okay, thank you. So Malhotra sir, would you like to make an opening statement?
See, the question which you have said is that when will India fully utilize the real world application? The real world hydrogen applications can be fully utilized or freely utilized when the cost comes down. The affordability is the key. That's having said that, the second part is that what government must steps the government. You want to know that possibly till such time the cost comes down, what the government doing, encourage the usage of green hydrogen. While in the earlier debate I was sitting there, and then I just added that the government, I think ISTS somebody mentioned, the government has already given interstate transmission favors, etc., banking of hydrogen, for banking of electricity, electricity for green hydrogen production, etc. So these kind of incentives do make it cheaper. The second thing is the carbon credits. When you produce green hydrogen, the cost can further come down because of the carbon credits, which the carbon credit and trading scheme has been notified by the government. And that scheme will also enable the utilization of green hydrogen by various sectors who will require that for the decarbonization of these sectors. Compliance markets particularly, they will some of them will do voluntarily also for ESG compliance, etc. When voluntarily they want to go to net zero. But the compliance markets will definitely have to use it. And I believe that will, indirectly the government's scheme of CCTS, carbon credit trading scheme, will force the takeoff of green hydrogen for that matter. What more government can do? I always believe that there is a limit up to which government can support. You know, you want the Indian economy to increase, you want the GDP to rise. You cannot make things expensive also at the same price, at the same time. So if you allow the more of expensive green hydrogen to be used by various sectors, you can't afford fertilizers to become expensive in this country. Okay, the refining industry can perhaps, use it and pass on the cost either to the customer, which may or may not be allowed, but refineries, government also feels at times that the refineries have sufficient margins and they can absorb. So these are some of the indirect things which the government at its level has been doing, and but there is a limit beyond which the industry needs to look at how to reduce costs. Dr. Ramkumar did mention in the earlier session that the target of 111, which was, I at that time also when $1 cost of per kg of hydrogen was announced, I was in the Federation of Indian Petroleum Industry, and one of my private refiner called me up immediately and he said, NTPC also announced that we will also produce hydrogen at $1 a kg. He said, you write to the CMD of NTPC that even if he gives at $2 a kg, I am willing to buy a long-term contract for unlimited quantity of green hydrogen to be purchased. So even if it comes down to $2, or I believe even $2.50, I think the demand will pick up. It is coming down. What possibly the state governments are giving incentives. Progressive states like Odisha had announced now today, the Honorable Chief Minister of Andhra Pradesh, he went to an extent of saying that you tell us which state is giving what and we'll match it or even do it better, So if that thing's already declared, so if such progressive states are pushing, I think things will happen. So let us hope that the green hydrogen cost will come down. In the interim, I always believe that the government must step in and try to create infrastructure for supply and distribution of hydrogen. It was mentioned again by someone in this panel itself that the cost of transportation and storage is equally important. So government can step in and try to help create infrastructure for supply and distribution of hydrogen. So far, I found that the National Green Hydrogen Mission, there is no support for the infrastructure creation. And this is one thing where the government, because the infrastructure will be used as a common carrier by all the companies can use that infrastructure. So no single company would like to invest, and it can be a common infrastructure which can be allowed to be utilized by any player of hydrogen. And this must emerge as one of the recommendations maybe from this conference. I'm sure Mr. D.N. Rao, sir, will be listening, that one of the recommendations which possibly can emerge from this is that government needs to support the creation of infrastructure, the central government, because this infrastructure is going to be used for supply and distribution of hydrogen by all the green hydrogen producers. No single green hydrogen producer can create infrastructure of its own for supply and distribution, like we have for natural gas. We have a natural gas pipeline which is created by the government and is being utilized by all natural gas players. There is a talk which is going on at present that even the petroleum products pipelines, etc., should also become common carriers, although some of the companies are reluctant. So I think that this point of time we should create some kind of that kind of infrastructure, and that is one thing which government needs.
Hello. Yes, I now move to Mr. Ravi for his question on, and the question again is, what can the government do in the next 12 months to accelerate green adoption?
Yeah, thank you so much, sir. Sujit ji. See, for a immediate, relief or whatever we are talking about, a couple of things. Like one is a common creation of a common infrastructure definitely help us. And then very important thing today, the most of the people for a green hydrogen production, we are choosing a route of electrolysis. Hope everyone agree with me. So now the biggest cost for us is in electricity. Okay, earlier days electricity was okay, but now because of a stringent rules of banking policies of individual states as well as the whole grid, it becoming challenge. I do agree there is a challenge for a grid also for a stable, and then they're looking at best as an option for them. But again, as a green hydrogen, when we are trying to do, as they said, ISTS charges they waived off completely, and they're giving a lot of other things. But one key elements can really change the game is please make banking as a zero or probably allow us to bank more energy so that even I can establish my solar energy somewhere in Gujarat and still I can consume here, and then without paying anything on a banking, then probably even the best electrolyzer today at 45-50 kilowatt hours, and then I can produce at 2 rupees. So what sir was talking about, $2.50, I can easily produce hydrogen and give it to the industry. Right, sir. So another coming 12 months and probably some policies, something like this encourages, things will change drastically. Industry is looking for it.
Hello. Yeah, I mean, that's an interesting point you made about banking, right? But I have my reservations about that because banking as a concept, if you are using it, you might not meet the green hydrogen certificates and standards itself of RFNBO, right? So we need to be very cautious about using banking, grid banking, right? As far as green hydrogen production is concerned, rather work on electrolyzer efficiencies, proper management of wind, solar, and any other storage system. So that's a quick comment on that. But I think in terms of what we need to do is, look, I mean, today all the projects that we're talking are at concept level, right? Maybe at the pre-feasibility stage. Somehow we need to push this project to reach FID stage, which is a final investment decision in a period of 12 to 18 months. Because that's where we will really know at what point we are reaching, what is the difference, what is the kind of support that we need from the state. And so that's the critical path which will require the private sector to take certain amount of development risk, both in terms of capital as well as bandwidth, right? At the same time, we require certain support from the state and the central government to handhold and sort of push this process through, right? At this point in time, things will not be very clear to the developer or to the policymakers because this is a path which has not been taken and we are taking that path. So that's the 12 to 18 months kind of a framework that I see. And one important factor which could change this whole thing is that the moment we have changed our decarbonization efforts from electron to molecules, we are crossing geographical boundaries. Till the time it was electron, I was supposed to do it from Gujarat, sell it in Odisha or Odisha to Andhra. That's the market that we're looking at. But the moment we are talking about molecules, we are crossing geographical boundaries. And this requires reduction of geopolitical tension and a sane international trade order. These are the two things which could immensely contribute towards the reduction of delivered molecule prices. Thank you.
Mr. Garg, go ahead, please.
Thank you, Dr. Sujit, for inviting me. I'll talk a bit long term. Like since I was in CTU, so I have faced the difficulty of the subsidy part, and that's the ISTS waiver. solar and wind and all kind of renewables, they were given ISTS waiver, and that is lasting. I mean, the last date was June 25. The projects commissioned by June 25 shall get 100% ISTS waiver, and after that it is being phased out 25% each year, and by 29 it will be zero. And this is extremely painful to the RE developers, because whatever they decided in the beginning, for many reasons, the projects got delayed. The transmission system also got delayed. So they could not meet the deadline of June 25. And now they are facing problems in getting the PPOs signed, and many problems are coming up. The same thing should not be repeated for green hydrogen. But to scale up green hydrogen, definitely the initial incentives are needed. So I can say that subsidies in India cannot be denied. To start for any new thing, subsidies are needed, as we have done in case of renewable energy. Similarly, in case of hydrogen also, certain subsidies will be required, but those subsidies should not be long term. The subsidies should be front loaded, maybe for a period of 3 to 5 years, and there should be a clear indication that this subsidy will not be available after such and such period. So the developer should plan accordingly, and they should not feel any kind of pain when the subsidy phase will be over and there will be huge demand for extension of subsidy period. And certainly that may not be possible. Initially, the government should invest in infrastructure development. As everyone says, that building the infrastructure is not the baby of developers. We need to develop pipelines, we need to develop storage facilities, we need to develop port infrastructure for export purpose, we need to provide the bunkering facilities, we need to provide good ISTS infrastructure so that the RE can be sourced from the RE-rich potential zones of Rajasthan, Gujarat, etc. And because the green hydrogen production will be at the port site, so certainly the ISTS is very much needed. The state network alone cannot facilitate the most important input of renewable energy to green hydrogen. So, the regulatory framework, I can say that the good regulation is an alternative to the subsidy. If we are really putting up a very good regulation, if we are facilitating the developers, then subsidy is definitely not needed for a long time. Of course, electrolyzer production, we are right now dependent on the import of electrolyzers. That has to be taken care of by motivating the electrolyzer manufacturing, by providing the PLI schemes, and through BGF schemes, as I said, the infrastructure conducive to green hydrogen environment should be developed by government. And with this, with very small little subsidies, whatever have been announced, like by, Andhra is going, they are announcing, they are offering great subsidies, but still I say that there should be a deadline for the subsidy, and after that, market should take care of the rate, cost, and everything. Thank you.
Mr. Jairam?
Yeah, thank you. I want to highlight three policy interventions which might be very useful in the next 12-18 months. So one is green hydrogen purchase obligations. This also came up in the last panel. Definitely it would be good to have this for refinery, also for fertilizer. And the numbers which came up in the last panel with Dr. Ramakumar was 20% for refinery, 10% fertilizer. let's take the case of refinery. I think the target is almost 1 million tons of green hydrogen, right? So far they closed about 40 KTPA. The midterm target is about 200 KTPA. But for them to consume more green hydrogen, I think we need some mandates. So 20% for this sector might be useful. 10% fertilizer might be also useful. The second intervention which I want to happen is, this is a very complex subject. This is benefits were given to SEZ, EOU versus DTA. For example, Hygenco is set up in a SEZ, right? So which means it favors exports. But if I have to service local demand, especially let's say the Saki ammonia local demand, I give up all the benefits which I got being SEZ, right? So if the government is able to treat both benefits equally, meaning I'm able to also service the local demand with the same SEZ benefits of exports, that's a win for us plus the whole country. And third is I want to go back to the cost discussion which came from Mr. Shailendra, also from Mr. Malhotra, right? So price discovery recently we've seen it's about $4 per kg of green hydrogen. This came from two tenders, IOCL a couple of months back and recently HPCL. Our target is to get this below $3. How do we do it? I think look at certain low-hanging fruits. If you kind of waive off the intrastate charges, that's probably about 45 cents roughly. These numbers from published reports the last 1 year. Banking is debatable. If you bank, maybe you can't supply to Europe under RFNBO. And we as Hygenco know that because we already pre-certified for RFNBO. That will knock off, if you waive off charges for banking, that'll knock off about 35 cents. So that's 48 plus 35, almost 80 cents there. Then you look at GST reduction, what's today 18%, brings this down to about 5%. That's about 20 cents right there. So your $4 becomes $3 with these three interventions. And then add to it all the technology improvements, improve the efficiency of the electrolyzers. Then your $3 becomes $2.50 in the next maybe 3 or 4 years' time. And then now we're in the game, in the money.
Wonderful, wonderful. Thank you. I just like to mention something that you mentioned about the GST being reduced from 18% to 5%. So that is also something that has been taken up.
In fact, AP government for a green hydrogen ecosystem for whatever you would like to build in Andhra Pradesh, they waived off state GST also. Yeah, even their clean energy policy clearly indicates they're giving even a subsidy on the capex whatever you're going to have. Yeah, in fact we were trying that route only to establish one factory here in AP.
Also, the AP has waived off 50% of the intrastate charges for 5 years. So that's one more benefit which the state gives.
In fact, MNRE and CEW had published a report just a few months ago in which they calculated that the National Green Hydrogen Mission is providing a total support of 19,744 crores, as you know. But this total amount, quantum of state support is 61,000 crores. There's a tremendous, support from the states also.
I think, as you said, that $1 impact has already been created by Andhra by subsidizing the ISTS charges, by providing land at the reasonable cost and that SGST waiver. So I think every state can come up like that and $3 is workable.
And I think Mr. Jairam had also mentioned to me at lunch that I think now from 6 states which have green hydrogen policies, we have now 15 states, I believe, which have green hydrogen policies. So the momentum is picking up. There is some negativity from certain countries. I won't name them, but in India it's all positive, and we are in a very, very good situation to achieve our goals of the NGHM. Yes. So would anybody like to now, they've given me a total of 5 questions, you just covered 3. I'd like to maybe ask you, maybe paraphrase my question a little better. Is there any innovative policy that the Indian government can take up? Innovative in the sense of like certain countries like Germany have taken up certain policies like which you have mentioned in your report, for example, any innovative policy, any policy that has never been done before, or would you suggest?
I don't have much idea on this, but what all I can say is the R&D part should be dealt in a different way for green hydrogen. Like in our country, a particular lab does certain R&D. They don't consult with the industry. There's no involvement of startups in a systematic manner. But now for green hydrogen, certainly there are so many things like desalination of water. That is very, very important for green hydrogen production because we can't use the sweet water. It won't be sustainable. Then reducing the cost of electrolyzers, increasing the efficiency of electrolyzers. So then innovation in storage and transportation of green hydrogen. All these things requires a lot of R&D work, and that R&D can be done in collaboration, like the universities, startups, and industry. If all these three put together, if they take up the R&D work, then definitely we can achieve our requirements in the right direction. And for that, government has to come up with certain policies so that whatever funding is being done, that funding should be done to the consortiums, which comprises of these three factors: universities, academia, startups, and industry. And whatever they develop, that should become the national property. That's what I want, that government should intervene in a big way.
I want to add, I want to make one point if I can. So India is already innovative. If you look at ISTS, just tell me which other country has this kind of policy, this kind of waiver. No other country. No other country. So with ISTS benefits which India has, meaning I can set up my RE plant in one corner of India, let's say in Rajasthan. I can put up my ammonia plant in Andhra Pradesh. And there's no charge to transmit my electron, RE power, from the western state to Andhra Pradesh, right? So which other country has this? I think India is already innovative. The one area where we can do better or look at more closely is global continental partnerships. For example, I'm going to quote the H2 Global, Initio Global Tendering Process from Germany, right? So here we can partner with Germany. But Germany is a global demand pocket. India is a top supplier. So maybe we can partner together, pull in funds together under the H2 Global umbrella. And there can be a tendering only for Indian developers where we supply ammonia from India and is taken to the markets in Europe. So they can be, I'm not saying the innovation, but something we should look at closely.
It comes every time. ISTS waiver, of course, I am in favor for a certain period, say for 5 years. Beyond that, it's not going to sustain, because I'll tell you what is ISTS waiver. In fact, in ISTS, whatever transmission system is made for renewable energy evacuation or transmission, that is made a national pool. And whatever is the tariff of that transmission system, that is loaded in the national pool, and it is recovered from all the utilities who are utilizing the fossil part of electricity. And it is not being charged on the non-fossil, I mean renewable. Now you just see the renewable generator or user is not paying anything, but it is being paid by others. And renewable is used by the same people who are using the conventional part of energy. That means the money is coming from the same pocket, and there is no problem. If this ISTS waiver is not there, then their thermal component will come down, RE component will go up, and it will, all of us pocket will remain unaffected. But when we talk about the green hydrogen is is going to be used for purely commercial purpose, It is not for a very, very common person. So, okay, for 5, 6 years, it can be done because it is the country's requirement. But after that, if you do it, if you subsidize a refinery and the petrol is being used, whatever is being used by the rich people, then the poor will unnecessarily pay for the ISTS charges. But 5, 6 years, certainly it should happen to just ignite the spark. But flame should be market dependent. Thank you.
So, with this, I'll just like to summarize some of the discussion points that have come out. The first is that ISTS waiver, maybe which was supposed to, I believe, it expires in 28 now? 28 or? You want it for a few more years beyond that? 2030. Right now it's till 2028, right? Ferrari. But then green hydrogen is going to be extended. One more extension is required. Okay. Point taken. And then there was also a suggestion about the purchase obligation. So this is one of the one example of a policy decision that the government could take. Then there was a mention of all the progressive policies in various states. I also mentioned that it's much more than the National Green Hydrogen Mission outlay. In fact, more than 3 times the outlay of the National Green Hydrogen Mission. We were supposed to cover a couple of other questions, but in the interest of time, I'd like to thank all of the speakers for their inputs. I think it was very valuable. And I look forward to the report that we have the recording, and I think Dr. Rao will now give us a brief summary of the session and all that a little later once we do that. So thank you very much. Thank you.
I request the panelists to kindly be seated. Thank you for all our panelists for the insightful look at the future of green hydrogen in India. Now, I request Dr. Sujit Pillai to felicitate the panelists. To start with, Mr. Robbie Rajshekharan, KPI Green Hydrogen and Ammonia Private Limited. Mr. Shailendra Babota, Yamna Limited. Mr. PC Gal, NSEFI. Mr. Harish Jairam, Hygenco Green Energies.
Thank you, sir. Yes. Thank you. So now I call Dr. Kamalakar Babu Garu. He is the champion behind this event. He has actually supported us in all the respects, sending letters to all the industries. We have close to 40 letters he has sent, and many industries positively today here because of Dr. Kamalakar Babu also, one factor. And I kindly request him to come to the dais, and we would like to felicitate you. And I am requesting Professor D. Narayan Rao Garu for felicitating Dr. Kamalakar Babu Garu. So this exercise actually started 8 months ago, where we have met the nicest person, Dr. Kamalakar Babu, one day, and then we thought of interacting with industries through the government of Andhra Pradesh and Red Cap. And now whatever you are seeing is all those 8 months of work we have done. I request. I request the audience to clap. So usually our working days are after 4:30 every evening, and it goes until 7:38, and discussing and sending letters, drafting letters, following up. And I really, the efforts and everything you have seen now today, how many industries are here. And one nice thing is every time when we go to his office, he will immediately say, "Did you drink coffee or tea?" That is how he treats us immediately. Kamalakar Babu Garu, thank you very much. So there is a couple of announcements. Of course, we are ready for it. Today we have a banquet dinner in Novotel. 7:30 it starts, and there is a bus from here 6:30. And whoever staying on the campus, they can catch the bus, and bus will return to the campus again. No need to worry. So, madam.
We warmly invite you to enjoy a refreshing tea break and explore the Green Hydrogen Expo in the lobby. Our volunteers will guide you, where pioneering innovations are on display and bold ideas are brewing alongside with your cup of coffee or tea. We look forward to welcoming you back tomorrow for another day of thought-provoking sessions and forward-looking collaborations. Until then, thank you for your presence and participation. This brings us to the close of Day 1 of Green Hydrogen Summit 2025. Thank you, one and all.